And just, I'm not going to give you the full marketing spiel here. This is a VMUG after all, but something I'm still quite proud of at the company is that our vision is something we've been sticking to for almost the last 6 years now. You've seen different versions of this slide from VMware people, and because we've been on this vision, really looking to software define every aspect of how you can manage apps and data and access them. It's definitely helped our customers to be able to more quickly pivot due to COVID-19, whether that's work from home, whether that's having far greater agility of their networks with Velo Cloud and Avi Networks or NSX Advanced Load Balancer, to the work that we're doing in terms of app and network modernization. We've even had an announcement earlier this week with the National Health Service of the United Kingdom's contact tracing app going live, and that was a partnership led through Pivotal Labs and VMware with the UK government, and even our VMware's very own Joe Bagley was very tightly tied into the government, the cabinet of the ministry there, and really helping from an advisement perspective and alignment perspective. So it's good to see these things happening. You'll see a tweet from Joe just in terms of that work actually being open sourced, which is quite exciting as well. So definitely challenging times, lots of good things happening. I hope all of you are staying safe in New Jersey. I've definitely been getting antsy. It's been tough with the parks and everything closed. At least they're reopened. I'd even taken my family to some of my old stomping grounds a couple weeks ago. We took our Jeep out to the cranberry bogs that are in Lakehurst, just because it's not actually a park. It's where I used to run around as a kid, and I figured nobody would be there. But I actually wasn't alone. There was actually quite a few people there on dirt bikes and different things, and a lot of people just had the same idea, just trying to get out of the house and just see some things. All right, so just real quickly on this too, in terms of just where we continue to look to go for our ops professionals, providing consistency in terms of infrastructure operations, networking, intrinsic security, really making it easy to run an app anywhere, provide that same management experience. You all know, you've been with us on this journey. That's still a work in progress, but it's an aspirational goal, and we keep getting better and better with each release in terms of making your life a lot easier and making it a lot easier to run applications in lots of different places. Because we have that consistent footprint, we continue to see a lot of momentum, even with the public cloud providers, in terms of looking to leverage VMware to expand their footprint of their apps and services. Because we literally are just about everywhere already. It just helps them accelerate their path to market. What's really key, and I know you're going to get really excited about Niran's session coming up next, is key to our strategy around developers is ensuring that their experience is native. So native tools, native APIs. You'll hear probably Niran say kubectl like 12 different times in his session. Sorry, Niran, but you get the point. And whether this is something like Kubernetes or even Amazon RDS running natively on vSphere, in that case, you're using the Amazon tools, the Amazon RDS APIs or the AWS Web UI to manage it from the developer side. And then the ops team is still getting their consistent VMware environment. So this is just a good way, I think, a very pragmatic way that we're bringing developers and ops teams together. As many of you know, for lines of business, key to a lot of the work we've been doing is driving greater agility and flexibility. I like to use the phrase flexibility as a design principle. That gives you the ability to just bake in the unexpected. And that's a lot of where we've been driving R&D, is to say, we don't know what's going to happen tomorrow, but let's make sure that there's a way to pivot based on some of that unexpected, whether that's a new security need, a new app, new data service, whatever it might be. We want to make sure that through our software, it's very easy for our customers to be able to take advantage. So I wanted to kind of split this presentation into two different sections. The first part is on business continuity, which I'll probably spend about 5 minutes on, and then the rest is purely based on innovation and some of the different innovation projects that we've been running over the last couple of years in the CTO office at VMware. So just on the continuity side, again, you've probably been hearing about business continuity too much, so I just wanted to be relatively quick here. We continue to see good data backing the point that knowledge workers like the option to work remotely, by a fairly overwhelming demand, and it's definitely driving even job satisfaction or where they would prefer to work. We're also seeing increases of productivity, which is, for me, I could tell you, it's kind of good and bad. My team has been just crushing it from a productivity perspective, but I'm like just working all hours, just trying to keep up with the flow of new work that's coming out of my team in the corporate office of the CTO, because they're not having to travel to meetings, they're not even having to walk between meetings. They can, just get up and start working from home. And we're definitely seeing across VMware a significant gain or rise in productivity across the different teams, which is definitely exciting. The key there is, of course, to make sure that we're stepping back and just taking some time to get away from the desk and still space out our days appropriately, so that we can sustain this. Now, there's 3 areas that VMware has focused on, and again, I'm just going to touch on these briefly here before getting into our new innovation projects. And those have been around Workspace ONE. That's really been super influential for our customers due to COVID-19. Somebody I talk to quite frequently is Venu Thomas, who's the CTO at Presidio, and a couple of weeks ago he was sharing with me how they had used the Horizon broker to connect hospital staff to their physical PCs in the hospital office space so that they're able to work from home. And they were doing that using the HTML5 web client. And I'm sure many of you have seen similar types of scenarios in your jobs as well. We're seeing after that initial pivot to how do I get people to work from home, the next thing was, well, how do I make sure they're secure? So we're seeing a lot of interest in Carbon Black as well at this point. And I'm really excited. I know Niran, again, giving Niran a lot of love here, as well as Frank, Chris, and Jason. Man, NSX is really helping this agility to fly because when you have that fully software-defined network, you can do things so much quicker. This is how some of our customers were able to very quickly pivot workloads into AWS or Azure data centers following shifts in how they had to work. The advanced load balancer, or AVI networks, is really strategic here as well. And I'm going to have a couple slides on this in a bit, so I'll share those details there. This just real quickly here. Again, you've heard this from VMware folks quite a bit. It's a mess, right? Getting all of this to work together is not easy. And this is where we continue to drive Workspace ONE in terms of being that solution that can tie all of this disparity of apps and data services together. And at the end of the day, I like to look at this as really more agile business continuity, starting with being able to get access or contextual access to my different apps and services through Workspace ONE Access and the verified services. I recently had my VMware laptop die, and I was able to just use my personal laptop. Through VMware Verify, it realized that I was coming in from a different device, and I had to do a multi-factor authentication with my RSA token. But again, once I got to the Workspace ONE portal, I was then able to access all of my corporate apps, my different services that I needed without having to log in multiple times. The other area here that I think has really been important that we've seen a rise on is through VeloCloud. I have a VeloCloud Edge box that I run in my house. It's been absolutely phenomenal in terms of maintaining consistent performance for my different work applications. It's really key when you have teenagers in the house like I do that are trying to stream at all hours of the day and giving them a miserable user experience in some cases so that I can get an optimal corporate experience. It's tough to be a teenager, I guess. That's all I tell them. The struggle's real, but VeloCloud has been a phenomenal improvement for a number of our customers. Probably the best case I've seen is we had a insurance provider roll out 5,000 VeloCloud Edge devices as they shifted their call center to work from home, and that occurred in just over the span of a week. So again, being able to just plug it in, do remote activation, and download policy makes this flow very seamlessly. Been a big fan of AVI networks even before we had acquired the solution. And again, as you start to pivot workloads to different branch office facilities, different plants, different data centers, when you can have a control plane that lives as a SaaS service in the public cloud, and then have a data plane that is literally also software-based and can run anywhere, it gives you a massive amount of flexibility in how you can very quickly pivot and restructure some of your infrastructure operations when these changes occur. Far easier than having to deploy metal somewhere to bring an ADC to a particular locale or endpoint. All right, told you I was going to blow through business continuity pretty quick. Man, I'm only 4 minutes into my time budget, and we're already shifting to innovation. So I feel pretty good about that. So this is going to be some more of the new stuff. I can't talk about innovation without at least giving you the Tanzu intro. This is something that's really strategic to the company. I think all of you in the VMUG community are certainly well aware of that. Niran's going to give you the deep dive, so I only have one other slide on Tanzu moving forward. But you're going to continue to see far greater acceleration from VMware this year through Tanzu Kubernetes Grid, giving you the flexibility to run consistent upstream Kubernetes anywhere you prefer, from the public cloud to the data center or branch facilities. VMware Cloud Foundation with vSphere 7 with Kubernetes, giving you a fully curated Kubernetes experience that's just baked into vSphere. And I'm going to talk about that a little bit next. And then finally, Tanzu Mission Control, giving you that centralized observability and management across clusters for anywhere that I'm running my Kubernetes pods. Now, one thing that, while we hear Kubernetes, what I hear sometimes when I go to VMUGs is people say, well, why should I care? My company's really not doing much with Kubernetes. And the way you want to think about this is Kubernetes is the first use case for Project Pacific or vSphere 7 with Kubernetes. This is becoming the means by which we will integrate new apps and services into our stack. So whenever there's a third party that wants to run their PaaS services on VMware, we have a standard way and an open way by which they can drive that integration. And it becomes very easy when you're supporting different lines of business. If they want to run fill in the blank on any type of new service or app on anywhere that you have a VMware footprint, well, hey, does this have a Kubernetes operator? If so, well, guess what? Going forward, we're going to have a way to make that just a very seamless experience. So, from supporting your business units, they have a very streamlined way by which to run their apps and services anywhere. And then underneath, it's still the same VMware that you know and love. So you're going to be able to continue to manage through vCenter and VROPS and all of the tools that you've been able to take advantage of historically. So again, it's just a good coming together. You'll see a lot of work happening here, and you see some different names. One of the terms I like to use is disaggregated cloud services. You might hear local cloud as a service. The bottom line is, going forward, I can't share some of the things that are really on the horizon here, but we will be talking more about these at our Empower conference in a couple of weeks. So if you're registered for that and you're a VMware partner, you'll get to see some of that news. But we're making good progress in terms of extending capabilities to run even public cloud services on VMware infrastructure. What you see on the right is some of the recent announcements that we've had with our cloud provider partners. The key here in getting these services into vSphere has been just making it easier to bring the cloud to you when it doesn't make sense to bring workloads to the cloud. And sometimes that's because of data sovereignty or regulatory compliance. You might have integration with some legacy app or data services, and it just starts to make more sense to bring that service in closer. I think Amazon RDS on vSphere is a great example of that. Database as a service is something that everybody has to do. Nothing particularly differentiating about it with IT organizations. So this becomes one of these things where if I can just bring this into my data center and consume it as a service, now the maintenance of the database platforms, the lifecycle, the snapshots, replication, backup, et cetera, is just delivered as a consistent service. And that just frees my DB admins to focus on other interesting things or additional work. But again, you might say, well, I want to consume that as a service, but I want to build some differentiated IP for my company, and I want to have more flexibility there, not tie it to a single cloud service. And this is where Tanzu Kubernetes Grid is really important and strategic for a lot of our customers. All right, now let me talk about the CTO office. This is kind of like our marketing-ish slide in terms of where we're focused at the CTO office in VMware. It's really around catalyzing disruptive innovation and making sure that we're co-innovating. So I'll talk throughout this about some opportunities for all of us to work together on a variety of different innovation projects. And this is a really key focus of the CTO office at VMware over the last couple of years, is making sure that our customers, our partners, our VMUG members are an integral part of the innovation process. We like to take very early stage ideas, start to bring them out to community members, socialize those ideas, and get some feedback, and then that can start to accelerate a number of different innovations. I mean, it was literally right around a year ago, just over a year ago, that I had done a demo at a VMUG, which was running ESXi on a SmartNIC. So it was ESXi on ARM running on a SmartNIC, running a couple of different network services, fully virtualized. And first time we had shown anything like that, we did it at a VMUG because we wanted to test reaction to, how serious are people are interested in this whole SmartNIC phenomenon. And as it turned out, there were thousands that were really excited about some of the opportunities. And that's actually now, since then, has driven a number of innovation initiatives in VMware R&D that are focused on SmartNICs and SmartNIC opportunities for the company and our customers. Again, that started with just doing some socialization at some different VMUG events. This is an area, if you look in the blue/purple bar across the top, where VMware's CTO office is doing a number of different innovations. And I'm going to highlight a couple of these as we go forward. We're going to have a couple of demos. Just one is going to be around telco and 5G, as well as virtual and augmented reality and some projects that we have there. But we are literally working across all of these. Crypto agility is an example of an area that in my organization, Dennis Moreau has been focused. And you might have heard quantum readiness as being thrown around a lot, and we're tending to start to use the term crypto agility to talk about doing a full inventory of cryptography across our software stacks, and then B, understanding how do we modularize that to make sure that we can replace an algorithm if it might be threatened by, say, future quantum abilities to be able to crack more sophisticated algorithms. So these are some areas where we're investing. There's a lot that happens in hardware acceleration. There's two members of my team that focus specifically on what's on the horizon upwards of 5 years out from Intel and AMD. So we have labs inside VMware where we get very early hardware prototypes that we can start to test and understand how that can integrate with our stack. And the job of this part of my organization is to ensure that when these new features are available and shipping from the server OEMs, that we have day zero support in products such as vSAN and vSphere and NSX. Now, in terms of the co-innovation model, as I had mentioned, we do like to get our customers engaged. We're even looking to pilot this year the ability to co-develop some new features with select customers. So this is going to be a new effort of the CTO office in partnership with our professional services organization, where when we've identified customers that are definitely wanting some capabilities that are just a bit further out on some of our product roadmaps, we're looking to accelerate innovation of those capabilities where we can co-develop those capabilities with the customer and graduate that into our R&D business unit, which would then become a shipping feature. So it gives you the opportunity to work hand in hand with VMware engineers to build a solution that becomes a shipping product at VMware. If you have some of those use cases, I'm definitely interested in hearing about that. We have a couple of customers that we're looking to line up right now to be that first stage pilot. But we're definitely interested in exploring more of these use cases and getting feedback from the VMUG community. If you have ideas, if I can't get to it through the chat or the Q&A, then ping me on Twitter, send me an email, send me a note on LinkedIn. Any way that you'd like to just get a hold of me and share some of those ideas, we're definitely interested in learning and moving forward. Something I didn't fully just discuss at the start of the presentation, in VMware CTO, we had done a reorganization at the very end of last year. And the team I now lead is called the Advanced Technology Group in VMware's CTO office. And our charter is incubating off-roadmap technologies that are on a sub-3-year horizon. In many cases, we're primarily focused closer to 18 months out, just because the world is changing so fast. And that allows us to drive some new innovation with a greater sense of urgency to time to particular market needs. These are just some of the different programs that we have in the CTO office, just for your awareness. I'm sure many of you have consumed technology through Flings in the past. We're continuing to drive new capabilities through the Flings program, and there's more on the horizon in the not too distant future. We've just greenlighted a new project through our XLabs program, which I'll explain in a second, that drives towards this direction. Also, through our CTO ambassadors and our global field organization, this is where you have VMware experts, such as some of the folks here, such as Niran, that participate in this program and really help to align what's happening in R&D with where the needs of our customers truly sit. So we try to add a lot of pragmatism to the R&D process. One of my least favorite quotes, because I see this circulated too often, is the deal about if Henry Ford asked people what they wanted, they would have asked for a faster horse. That's fine, but for literally over 100 years now, or about that, people are still using that to justify why they don't have to talk to anybody and just kind of come up with ideas on their own. The world doesn't really work that way in many cases. We've had far better success with innovation, working hand in hand with our customers, our VMUG leaders, sharing our ideas with them and getting feedback early on in the process. And it's letting us just ship better, more quality products that are more aligned to our customer needs. Now, here's an example of some of the recent projects that we've graduated from the CTO office. I mean, Project Harbor has become the de facto container registry through the CNCF, and that was initially bootstrapped out of the CTO organization that's in China R&D. Many of you have participated in the Folding at Home virtual appliance. Just tremendous job by Amanda Blevins and William Lamb in leading that effort. And if you haven't seen that, just navigate over to our Fling site and hop on. This is allowing a global community of computers just running even a VMware virtual appliance to participate in critical R&D modeling, inclusive of looking for solutions for both the treatment and also having a prevention of COVID-19 through things such as vaccines. The predictable response time controller was led by Ahmad Benjamin's team in the CTO office. And this is a key integration of Tanzu Service Mesh, which it's Niran's presenting, so he's absolutely talking about Service Mesh. So I'll go ahead and leave that to him. It's one of his favorite topics. And then finally, I will have this is my virtual demo today. We've recently graduated our virtual service network technology. Again, I'm going to deep dive on this in a little bit, but this is providing prescriptive quality of service end-to-end across radio access networks all the way out to, say, a cloud or data center endpoint, so that I can get end-to-end quality of service or even traffic prioritization for different workloads that are connecting through 5G or mobile networks. Again, as we become more and more distributed in nature, we see this technology as being really important. Konstantin Paikounopoulos was the founder of this project, and he had also founded a company called Byte Mobile, which was acquired by Citrix a number of years ago. I really had the pleasure of having him in my organization for more than the last 3 years, and the team's just been absolutely phenomenal. So you'll hear more about this technology going forward later in the year, something we're incredibly excited about, and we see a lot of potential there. Okay, so speaking of that, I want to go ahead and just shift a little bit and talk about XLabs. This is our internal accelerator program at VMware. We look to drive innovation through collaborative relationships with our employees, partners, and customers. So we really kind of look to open things up in terms of how we can drive new innovation through our XLabs programs. Now, as I mentioned, we try to accelerate quality ideas. We have dedicated budget, dedicated engineers that can help drive some of these new ideas into prototype and then ultimately into production. We spend a lot of time working very closely with our different R&D business units at VMware to ensure that the work that we're doing in XLabs can just seamlessly slip into code that they've already developed. So we don't just try to hand them a prototype where it looks like a good idea, but they would have to then start all over again. We try to do a lot of this work hand in hand with the R&D teams, which really accelerates the adoption of the different types of incubation projects that we have. I thought you'd find this interesting. This is a heat map of the different submissions that we have for XLabs. And you can see that it's really across the board in terms of where the different interest is. We are seeing a lot of submissions around using ML for different use cases, as well as automation. And in many cases, these are just augmented capabilities that customers are looking for tools such as VRA. But again, it's fairly across the board in terms of where we're seeing different submissions come from. Again, this is organically in the CTO office. This is from different R&D teams globally across VMware. This is really a landing place where anybody with an idea is able to have that idea accelerated and developed. That's been one of my favorite things at VMware is it doesn't matter what part of the company you work in. If you have a good idea, people objectively will just look at the idea, and through X Labs, we can actually give you investment and engineers to see that idea forward. Now, this is an example of a recent smaller graduation. I just want to mention because it's really cool technology. This was initially called Project Wormhole. It was renamed to Flowgate and released as an OSS project. And you can see this on our GitHub page if you want to just navigate there and check it out. The idea here was to be able to integrate some data from your different facilities with the IT stack and tools such as VROps, so I can do greater observability and management of my facilities data in my data center. So we've seen a lot of interest in expansion of these use cases, and we're investing even deeper into doing further automation around some of your data center facilities data through cooling systems, heat probes, lots of other feeds, and driving a lot more automation around that. So stay tuned. There's some really good work that's happening there. And it is folks like you see here, like Gavin and Yitsing. These are in our China R&D office. And in the US, if you've ever worked with Daniel Beveridge is very closely tied into these efforts as well. Sorry for all the name dropping, but I get to work and manage a lot of really smart people, and I like to give them shout outs when I can. And speaking of smart people, next project I want to talk about is Project VXR. Sure many of you have seen Alan Renoff's demo with Pat Gelsinger on stage at VMworld a couple of years ago. And this has really gotten us into a number of really interesting use cases, such as immersive training, which is coming up. And I don't want to just give all the credit to Alan. Matt Coppinger has been a really key leader of this program going forward. And due to COVID-19, we're seeing an increased expansion of use cases for virtual reality technologies. Design visualization has, we've seen that. Being able to augment workflows, so having augmented reality to improve the quality and be able to provide guidance in terms of where things go. There's a lot of times I wish I had this for when I work on my Jeep Wrangler, because it's often I'm either printing something or I'm looking at something on my phone, or even sometimes it's a YouTube video to be like, where the heck does this part go? Especially if you're just trying to customize, which I like to do quite a bit. I'm a bit of a tinkerer with my cars, but I can definitely see how even in broader manufacturing organizations this can be really important. We're seeing a lot more use cases around media production, and again, a good shout out to the Mandalorian. If you haven't seen that yet, great series. If you also had seen Narcos, it is a little weird at first with Agent Pena playing Mando, but you get used to it. All right. So live events, this can be even more interesting. It's definitely something I am concerned about. I would love to have that immersive experience. It's going to be interesting to see what happens. Hopefully our NFL is back online by the start of the football season. It's certainly important in the Wolf household. And we are seeing, again, a number of improvements in terms of productivity and training effectiveness through these solutions. But at the same time, there's a lot of challenges in terms of device management, onboarding, security, identity and authentication and access for those devices, being able to integrate those apps with different data sources and being able to measure performance and have analytics across all of these. And that's really what's gotten us to Project VXR. The goals of this project for these different devices have been able to provide centralized management and secure access. Again, this really gets to our any app on any device strategy for VMware. and again, providing that native AR and VR enterprise user experience. Now, I want to provide one demo to show you augmented workflows in the manufacturing facility. And this is where we do have a large global manufacturer that is interested in doing a highly scalable use case with us in this space. And this is, again, by highly scalable, this is way beyond 10,000 users and devices as at least part of their initial rollout. So pretty exciting energy and uptick behind these projects with large VMware customer base. And if you have use cases here, definitely want to hear from you, or reach out to Alan Renoff or Matt Coppinger, and they can definitely get you plugged in. That would actually be the faster way than having to go through me. Now, this first demo I want to show you. It's kind of hard to demonstrate VR over Zoom, so the video here is going to give you the best way to really see the experience. So what you're going to be able to see here is actually being able to do augmented reality workflow to help guide the full assembly of a Dell server. So you're going to see the instructions here. And one of the nice things about your workspace in AR or VR is you really have a 360-degree view. So it's not like I just have this small working environment by which to work from. I can have multiple computer screens all around me, different chat sessions. Literally anywhere I look, I have this continually expanding world by which I have screen space. So here we're going into the fan installation. And as I go down, what you're going to see here is the fan is giving me some guidance here. I see that virtual device that's showing me exactly where to put that first fan. So I can go on to the next step. And now I'm just going to be adding in the second fan, and this is going to continue through all of the different parts of the server, where I'm seeing exactly where to put each component. This takes me back to some of my early IT days in the 90s, where I was working with somebody who was one of the first MCSEs, and we're like, wow, this guy's got to be brilliant. He's an early MCSE. And he really could have used this type of training, because he was trying to put RAM into a server, and the DIMM, he had the wrong pin size of DIMMs. I think it was like a 72-pin DIMM at the time. So what he did was he just used a pair of pliers and he cut the pins off so the DIMM would fit. And we're like, what are you doing, man? So anyway, he effectively let the smoke out of the motherboard and fried it, and all we could do was just scratch our heads. So that was my first MCSE experience, but I actually later went on to get my own MCSE, so I've kind of been there. But again, you can see for somebody that's a bit intimidated or looking to assemble the server, having this fully guided experience, right, is giving you a really easy way to kind of streamline the training without needing somebody to be hand in hand with somebody else to walk them through this. So again, this gives you a taste of the project, and beyond just some of these capabilities, it's all of that back-end work, being able to integrate single sign-on through Workspace ONE and have that centralized place for device management for all of these different devices, and have that security. And again, being able to provide that seamless experience across even other apps that you might want to bring into this virtual workspace is really, really cool stuff. So again, Matt and Alan and the team are just doing incredible work. They've been just, for what they've accomplished with such a small team, it's quite incredible. Again, a really exciting project in the CTO office. I did want to get into the next bit of technology in the next demo, which is with 5G network slicing. And again, this is a recent graduation from the CTO office to our Telco Edge Cloud business unit. And as you can imagine, especially even more so today with the need for real-time healthcare, a variety of new applications, trying to do more training through augmented or virtual reality, so that I have safer ways to train in close quarters. These are just a number of use cases that are continuing to grow for 5G. Now, some of the challenges that we've had with network slicing are being able to scale to support all of these different devices and services, and be able to intelligently provide the right quality of service for each of these different services, and be able to provide the right SLAs. And this is what slicing is all about. I can have isolated end-to-end network with prescribed QoS SLAs and be able to prioritize from the device across the radio access network through the internet and then out to whatever type of device or endpoint I need or server application. This is a bit more detail here in terms of what I get in telco. Again, each slice would be an isolated virtual network for a particular use case. Again, I can slice per tenant, I can slice per application type or a particular use case. Again, I can do as many of these as I want, and I can just start to layer orchestration on top to drive across these different use cases. Now, this is our virtual service network architecture, which is again slicing from, say, a mobile endpoint through the radio access network, and again being able to provide different quality of service for different tenants that access the network end to end. And this can traverse anywhere from the enterprise data center to an edge site to a public or private cloud. Again, we're orchestrating and managing across this. Again, this is technology we've shown at VMworld a couple of times, or really the last couple of years as it started to progress. But now we've gotten really far along with this. And what I want to do next is
Welcome to the VMware demo on 5G network slicing. We will present an innovative solution that VMware is developing.
So this demo from Mark Andre is going to show you really the full capabilities of the stack and what you can look forward to. Shoot, let me back up here. Okay.
Welcome to the VMware demo on 5G network slicing. We will present an innovative solution that VMware is developing for orchestration of 5G services. We call this concept a Virtual Service Network, or VSN. Let's briefly discuss why network slicing is needed. In the 5G era, the demand for network services will explode due to new services like IoT, connected cars, and enhanced video services. However, existing networks are not agile enough and cannot scale to support such a demand. The solution to realize the full 5G vision is network slicing, which allows for the creation and management of isolated end-to-end virtual networks with prescribed quality of service. This demo will present the main functionalities and benefits of the VSN platform. But first, what is a VSN? A virtual service network is a collection of end-to-end network slices assigned to a tenant and customized for a particular use case with prescribed quality of service. The VSN architecture is tailored for highly distributed multi-domain and multi-cloud deployments, covering the edge, transport network, private, and public clouds. The slices also extend to the radio access network for complete end-to-end traffic isolation and SLA enforcement. The VSN orchestrator performs service orchestration, distributed control, and lifecycle management of the end-to-end network slices across the telco cloud. It also further delegates management of slice subnets to domain-specific VSN controllers. Finally, the VSN platform exposes open APIs for integration with other services such as OSS, BSS, monitoring, and web-based management systems. Now, let's have a look at the demo topology. Here, a tenant in public safety has used the VSN manager to orchestrate a purpose-built network slice for high-priority web access. This end-to-end network slice is composed of three distinct portions called slice subnets: the radio access network, the telco core, and the data network. These slice subnets run different virtual and cloud-native network functions that were automatically placed in the multi-cloud environment according to their latency requirements. We have also deployed a VSN for a mobile virtual network operator. The MVNO has a lower priority than the public safety VSN, but otherwise, slices and services provided by the two VSNs are identical. Let's demonstrate end-to-end network slicing and SLA enforcement by attaching real smartphones to our web slices. To the same base radio station in our lab, the phone on the bottom is attached to the MVNO slice, while the phone on the top is attached to the public safety slice. When the public safety VSN is idle, the MVNO is allowed to make use of the extra radio resources, and in this case achieve throughput that far exceeds its requirements. However, when there is new demand for the public safety VSN, any extra resources given to the MVNO's VSN are reallocated to make way for the high-priority traffic in the public safety VSN and slices. To achieve such optimization, the VSN platform relies on dynamic resource management instead of static resource reservation, It allows for oversubscribing the multi-cloud infrastructure instead of over-provisioning it, resulting in better use of the infrastructure and leading to significant CapEx savings. Now that we've demonstrated end-to-end network slicing and SLA enforcement, let's take a look at some of the more advanced network slicing features of the VSN platform. A user in the public safety network needs to make a video call that has more requirements than standard web traffic. The network slice selection function identifies the video call and steers it to an isolated mobile broadband slice that guarantees high throughput. The slices and the public safety VSN both share the same RAN and telco core slice subnets, but the video slice has an independent SLA that is enforced along the entire data plane and has a local breakout to the internet at the edge cloud. In conclusion, the demand for new network services will explode with 5G. The solution to realize the full 5G vision is network slicing. VMware is developing virtual service networks as an innovative approach to 5G network slicing, which will allow mobile service providers to operate as meta cloud providers and deliver end-to-end network services on demand.
Come on, right? That's pretty cool. Really excited about the work that the
Welcome to the
VSN team has done. And on top of that, one of the other groups that I get to manage is our machine learning program office in the VMware office of the CTO. And if one thing I hope you could appreciate is, like, sometimes I look in the mirror and I'm like, what even gives me the right to manage these people? They're just so incredibly brilliant. And Josh Simons leads the machine learning program office across VMware. And what I want to do is really talk about some of the work that he's doing and just some of the cool nuances that are kind of geeky that I think are pretty cool for machine learning that I thought my fellow VMuggers would appreciate. So just to kind of close things out here, we at VMware look at machine learning across three different pillars. First is what we call smarter businesses. So this is ensuring that the customer ML workloads can run well on our platform. So anything that you want to run as an ML workload or do some localized inferencing, connectivity to GPUs, et cetera, runs well on vSphere. So there's a lot of work that's happening there. The office that drives that innovation, if you're curious, is actually not far from here. They're based in Boston. Smarter VMware is using machine learning to improve the efficiency and productivity of our products. And some of these are pretty interesting. You know, we have a project right now in X Labs that's looking to automate the accessibility testing of our different interfaces. So as we're rolling new UIs out or new versions of UIs out to our customers, we're working on a project that will automate the accessibility testing to make sure that all the accessibility capabilities are present in those interfaces. And then Smarter Products and Services is injecting ML into VMware products to enhance automation scale and efficiency. And you've seen that through different keynotes and keynote topics such as Project Magnet in the past. Now, there's quite a bit of different use cases that's existing today for machine learning today, and I just wanted to kind of give you just a little bit of a glimpse of some of the different use cases that we see in regards to classification, which is probably one of the more popular use cases, such as image classification today, being able to run diagnostics, identity fraud, et cetera. And again, there's quite a bit that's starting to drive a lot of our customers into these different use cases. This is pretty interesting. If you haven't seen this, just head on over to thispersondoesnotexist.com. These are all images that were generated by AI. They are not real people. And it's pretty fascinating. And I already see, kind of looking at the Zoom feed, it looks like some folks are already hitting the keyboard. I was seeing you want to see some more. So pretty cool stuff. Adversarial attacks are also pretty interesting, right? I think all of us as humans, we can understand that this is a dog. But if you can just inject a little bit of noise into the system, this is actually what happens. So again, to us, this looks like a dog, but the algorithm that's actually doing the image recognition here is identifying that as an ostrich. And again, you can see the link here in the Medium article that had published this study. This is just another example of an adversarial attack. And this is really interesting in the context of self-driving cars. So again, to us as humans, okay, somebody messed with a stop sign. But in this case, the local inferencing that's trying to interpret what that is, interprets this as a speed limit 45-mile-an-hour sign. And that's kind kind of dangerous, right? It shows you the dangers of some adversarial attacks that can happen and how that can actually drive the localized inferencing. So when a decision is being made in real time on that autonomous vehicle, things can go horribly wrong. This was also pretty interesting in terms of growth, and this is model bias. This was an August 2018 study on facial analysis, and this was done by Amazon. And you can just see some differences here where lighter skinned males 100% accuracy for facial analysis, but you see some real challenges, especially with darker females being able to properly recognize and properly classify a gender. So that just shows, again, some biases in the technology and just the need for greater maturity in these technologies to be as reliable as they need to be. Last thing I'll mention here, just in terms of some of the cool thoughts around AI and ML, is around explainability. And we've had a lot of work in different parts of VMware that have been looking at this in particular. And again, being able to take some processes and a learned function and understand, okay, this is a cat and the probability is 0.93, not as really interesting for a user. So when you think about explainability, what that means is to say, okay, I can import that new learning process, input the image, and say this is a cat, and I think it's a cat because it has fur, it has whiskers, it has claws, and it has these types of features. So ears that look like this. Therefore, I'm going to make the determination that this is a cat. So now explainability has helped me to understand why the ML algorithm made that decision. And that's really key as this technology continues to mature. Now, where I also wanted to point you to as a resource is on the VMware blog site. We have a number of machine learning resources. And again, these are white papers that are produced by Josh and his team. And this really helps you from everything from Hadoop, virtualized Hadoop and Spark on all flash disks to how to leverage compute accelerators with vSphere 6.5. And again, there's a number of other or additional white papers that have been produced by his team over the last couple of years. So I definitely encourage you to check that out. They spend a lot of time on performance engineering and really making sure some of the more difficult and hungry workloads run very well. There's a university in Europe that they recently helped drive the rollout of a 50,000 core HPC cluster. That work was actually accelerated due to COVID-19, but that 50,000 core cluster is running HPC workloads all on vSphere today, which is really cool stuff. Okay, now you might be familiar with this. When we're connecting with compute accelerators, there's a couple of different ways to go. So using pass-through or direct path I/O is one of the more straightforward approaches. The consequence of using pass-through today, as many of you know, is that I'm going to break vMotion in the process. But again, if I'm not worried about some transients with those workloads, that may not be as big of a deal. If I want to have more flexibility and the ability to vMotion, then this is where NVIDIA Grid virtual GPUs come into play. The other technology that I'm sure you've heard about that we're quite excited about is BitFusion. And this has given us the ability to remote from a VM to a hosted server that's running, that has multiple physical GPUs installed. So this is really cool when you think about all of these different workloads where we're looking at high-end analytics, graphics rendering, we're looking at ML and inferencing. In the past, I had to have a GPU in every server where I wanted to do that work. Now I don't have to do that. I can simply remotely connect my client to a server over, say, 100 gigabit Ethernet, and then be able to remotely access those GPUs. So again, this gives you a lot more flexibility in how you can start to share these workloads and not have to just dedicate a server for one particular application type. Okay, so lots happening. I hope you've been able to see that. Again, it's always hard when I do these things to kind of pick, what I want to show folks today, because there really is just so much happening at VMware. Again, everything from acceleration to looking at how do I manage and orchestrate data that's living in lots of places, to crypto agility. And as some of these topics are of real interest to all of you, I'm happy to coordinate with members of my team to come on and share some of their work with you. So whether that's the acceleration work or whether that's some of the crypto agility work that Dennis Moreau is driving, Ahmad Benjamin's a fantastic resource around Service Mesh, but again, so is Niran. So you got Niran here today too, so you're also in good hands. Again, lots of things happening in Edge and just really across the board. And again, if you have some specific needs where you're like, man, I really can use this capability today, please reach out, because if you share that desire with a number of other customers, or you know of multiple customers that are looking for the same capability, this might be something we can literally get on to building in the second half of this year. So if that sounds like you, please reach out and let me know. Happy to keep this rolling along and on schedule. So let's see if there's any questions, and we'll go from there. Thank you very much.
Thanks, Chris. I haven't seen anything come up in the chat, but does anyone have any questions they want to unmute themselves and ask?
That was a lot of cool stuff.
Yes, it was. That facial recognition stuff was kind of scary.
Yeah, that was wild. And the stop sign, the AI feature-based stuff, that's crazy.
The augmented
Yeah.
reality, that was my thing. Like, I got to get my hands on that.
No, what's fun, what we do for VMware employees, we are 100% transparent on everything we're building. So like Niran and others, you go to our Confluence page for the Advanced Technology Group, and we have everything is just out there, and it's just fully accessible, because we want all eyes on everything we're building. We want to get a lot of feedback, and as much feedback as possible.
It's pretty cool.
Very cool.
Yeah, I thought it'd be fun with ML to kind of take a different slice, because we always just talk about the workload and performance. I thought it'd be fun just to talk about some of the geeky stuff and some of the weirdness that's happening right now, which is definitely interesting.
Yeah, definitely. Wow. Good stuff. All right. If no one else has any questions for Chris, then we'll take a 10-minute break or so and let people take a break and use the bathroom and stuff, and come back in about 10 minutes for Niran's presentation on Tanzu Service Mesh. All right. Thanks, everyone.
Ready?
Thanks, everybody.
Please. Thanks, Chris.
Thanks, Chris.
Please, everyone. If you haven't seen in the chat, I posted a link to sign in for today. If you haven't signed in yet, please follow the link and sign in for the day, so we can report back to VMUG headquarters who attended today and who didn't. Thank you very much.
Who knows what's behind me? Anybody knows what's behind me? What is that?
I know what's behind you.
What?
You said
It's
biosphere?
from Star Trek Picard, right?
Yes! Ding, 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 ding. We got a Star Trek fan here.
Yeah. The rock formation reminds me of when Kirk fought the Gorn.
Right.
Good stuff.
Okay, I'll be right back. Anybody here?
Yes, sir.
Yeah, why don't everyone open their like videos? I mean, isn't the whole purpose
Yeah, I don't know.
of VMUG is to be able to see each other?
That's what I was trying to say before, but I don't know. Too many people sitting at home in their underwear or what? I don't know, but
Hey, that's what virtual backgrounds are for.
exactly.
If you walk away, it won't, and you're in your underwear, it won't pick you up.
Can you see me? How do you see
Sure.
I just want to know, Ben, where are you getting your haircuts?
Where am I getting my haircut?
Yeah.
I went on Amazon and I bought a razor, and my girlfriend cut my hair. When you're almost bald, it's easy. You just set it to one length and do it everywhere.
Mine just goes.
Yeah, I hear you.
I'm receding this way. It's taking like a back way to the back of my neck.
Alrighty then.
Share my screen here. You guys seeing my screen? Can you hear me well? Everything's like operational?
Yes, sir. Everything looks good.
All right. We promised them 10 minutes, so 3 more minutes, something like that. I don't remember when we said that.
Sure. Yeah, that works. Everyone, again, please go to the link in the chat and sign in for the day if you haven't already. And also, if you have any questions for Niran or any other speakers today, please post them in the chat. Even at the end, it's going to be tough to have a bunch of people trying to ask questions at the same time. It's easier to post the questions in the chat and answer them digitally, or for Niran to answer them at the end by reading the questions versus everyone talking on top of each other.
Right. Shall we start?
Go for it.
Cool. So hey guys, my name is Niran Even-Chen. I'm a principal SC at the office of the CTO. Pretty honored that Chris said my name like a couple of times. That's pretty cool. So what I'm gonna do is, I know that not a lot of people kind of know what Service Mesh is. So I'm not gonna go into product right now. I'm gonna go and try and explain what is Service Mesh. Then I'm gonna kind of explain a bit about our product, and then I'll show a demo, because I think there's nothing like seeing it to understand it, right? But it's important to first understand what does Service Mesh mean. So I'm gonna go through that. And please, I mean, show a sign of life. Ask questions on the chat, or just jump in voice. It's totally fine. I don't mind about that at all. So, this whole thing started when a lot of the industry has moved from monolithic to microservices. And just so you guys know, a lot of companies are doing now some kind of a backwards on that, and kind of going a bit monolithic backwards on some instances, because it doesn't make sense for everything, but that's a different topic. But why microservices, right? So if you think about a monolithic app, right, like you see here, all the different services that are on a monolithic app, they talk with each other over RPC, and all deployed as a single chunk of code. Obviously, over the years, we moved from real monolithic apps to kind of a modular approach with 3-tier applications and stuff like that. But still, it's pretty monolithic. What does that mean? It means that if I want to update the code on the purple part here, I need to update the entire thing, right? So we talked about, you know, every 6 months roll-up updates and stuff like that, and an upgrade is a destructor thing. But mostly, it doesn't allow the business to focus on the business logic of each one of these services. When I say business logic, I mean, what does this service supposed to do for me? And all the rest is just non-differentiating stuff. It's just stuff that I don't care about, just makes the application work. That kind of was easier actually monolithic. Once we broke the application into microservices, that means now that the reason we did that, obviously, again, is to focus the developers on the specific service they're developing. And you know, there's the DevOps movement that it's all about reducing waste and reducing the amount of time wasted on different kind of things that you can automate. And we're talking about pizza boxes teams, where developers teams are smaller teams and are focused on the service they're developing. And this could be in a website where the purple service is the search bar, and let's say the green is the catalog of products or whatever. And I can update code directly to each one of these services separately, allowing me to continuously send code faster to my system. This is the idealistic kind of utopia of microservices. Obviously, things are never like that, and we'll understand exactly where the challenges are. But if you look at the microservices application now, first of all, instead of RPC, now every service talks with the other services over TCP/IP. This is a significant change of how the network operates now. Instead of just being different hosts talking with each other, it's now the bus where the application works. And there's a lot of implications around IPs and security and connectivity that we need to address. And obviously, that's where Service Mesh is coming. Also, because we allow the developers to focus on the specific service that they're developing, let's say this service here, they can develop them in any language they want. And now you need to make those things work together, even though one is Java, the other one is C#, another service is Ruby. And in addition to that, we want to allow them also to continuously update those services without needing to mess with configuration data. Let me explain what does that mean. So Service Mesh, most basic definition is that Service Mesh is an abstraction layer, right? We abstract out the service-to-service communication. Like things like service discovery, and I'll explain those things in a second. Service discovery, encryption, observability, resiliency, those things are abstracted. It's an abstraction layer. Let's see what does that mean. So if I look at a microservices application, right? It's an application with multiple services, as I said. Each one has their own kind of business logic. Each one is written very, very optimized to that specific service. We want to make sure we update them as fast as possible, and so on and so on. And we zoom into one of these services just to understand what does that mean. And this service, which is written in C#, is a web service. So the business logic of this web service is to get data and present it on a web page. That's if I'm the developer of this web service, that's what I care about. That's what differentiates my business, how I operate as a web service. All the rest, and we'll see now, is just plumbing. For example, this service now needs to know how to connect to upstream services, and now downstream services needs to connect to it. In order for this to work, they need first of all to find each other. That's what is referred to as service discovery. And I'm a developer, I don't know anything about infrastructure. How would I know how to tell service C to find my web service here so that they can operate together? So service discovery needs to be handled in some way. If I hard code that into my services, let's say I put connection details in my web service, this is non-differentiating stuff. This is not my business logic. This is just plumbing. And now I've made my web service, first of all, no longer like a microservice. It's kind of a microservice because it has additional stuff that are not focused on the business logic. But more so, if I'm pushing code to the web service, I need to make sure to take care of the connection details as well. I need to make sure to push the code alongside with the configuration, otherwise it won't work because it's part of my service. There's also the aspect of latency. As I said, all the services are now communicating over the network. Latency can be determinal to microservice application. If I have latency here, that means that service B is impacted because I have latency downstream. How do I find this latency? What do I do with the information? Someone needs to know how to do that. If I put that in my web service again, it's just non-differentiating stuff that my service now needs to handle. And if you look at just Java code on a traditional monolithic app, you'll see the code and what the actual code that does the application stuff, and then you'll see communicate with DNS, communicate with that, find a service like that, encrypt it like that. So all this is configuration data. Adding that into microservice doesn't really make sense. It's also about failures, right? What happens if this service fails? How does web service know what to do? Do it continues to retry? Will it move to the next service? It will handle this kind of scenarios. So all of this stuff is not part of my web service. Now my developer, which by the way, developers are the most expensive people you can hire as operational in your organization. My developer, instead of just writing web service, they also need to take care of connection details, metrics, and retries. Doesn't make sense. Waste of time and defeat the purpose of being in microservices environment. So that's kind of on the low level, the main challenge the service mesh is trying to handle. How does it do that? So we abstract all this stuff, all this plumbing, all this non-differentiating code. We abstract that to something called the proxy. Now, this proxy is a piece of code that basically handles the things here that are non-differentiating for me. But the way it does that is in a very cool way. Instead of going, we need to write code to do it, it's just configuration details. It's a YAML file that I can send to the proxy and say, retries 3 times, move to the next service. You find the services based on this domain name. This is the service discovery. Latency is sent here. Very, very easy to understand human readable YAML files. That is a Kubernetes style, which means that it's declarative. Declarative means that I just declare what I want. I don't need to imperatively tell it what to do. And it's reconciles all the time, meaning I send a configuration and make sure that configuration is always kept. So we abstracted all that to the proxy. Now all the communication will go through the proxy. We'll see in a second. Now what happens is my developers don't need to take care of that. Any DevOps or VI admin can take care of the service mesh configuration. My developer can focus on doing the web service. And even more so from a production point of view, if I want to push code to my web service, I don't need to push updates to this stuff. This stuff is now handled by the proxy. This is an abstraction layer, right? Now, I want to take a step aside. This is a VMUG. Everybody here is VMware folks, right? So let's look at another abstraction just to understand better how we take advantage of that and build products out of this abstraction. This is not, so think about, anybody here is like 20 years ago, VMware professional knows this image, right? This is the old VMware virtualization configuration, right? And what we had at the beginning, we had hardware, we had an operating system, an application with a one-to-one real dependency. And what we did, we inserted a data plane abstraction called the hypervisor and allowed us to do something called consolidation. And in the early days of virtualization, that's the only thing that we thought about. I mean, I'm sure there were visionaries thinking about, other things. Nobody thought about the cloud, I'm sure. But everybody wanted to do virtualization because it allows us to do consolidation. I call the consolidation use case number 0 of the abstraction called virtualization. This is use case 0, consolidation. And then everybody did a bunch of those. So we had to put the control plane, vCenter or VI, how was it called? Virtual Center, it was called. So we put an abstraction layer. As soon as we did that, it became a virtual infrastructure. So the set of data plane abstractions with the control plane became virtual infrastructure. It was no longer just the hypervisor. It now was virtual infrastructure. Now, the rules of physics started to change. We started to be able to move things around with emotion or get better resiliency with high availability. These are things that are not consolidation. These are new use cases just stemming out from using an abstraction, right? And now we could do better visibility. Before virtualization, you really couldn't know what's going on with your I/O. If it's slow, why is it slow? Like, is it because of the NIC? Is it the HBA? Is it because of the network? Is it because of the storage? With virtualization, with the abstraction, we could insert monitoring and observability, and we could see above and below the stack, so that now we know when an I/O from E6 stop, we could know that an I/O is slow because of the congestion outside of the hypervisor. We could also get better security. I mean, I don't need to sell you on NSX, and I'll let Chris and Frank also show you where NSX got to. This is another abstraction that we inserted in the infrastructure, in the virtual infrastructure, inserting security. Now we could also do a lot of policy-based management, which led to being able to automate everything and the explosion of cloud. And we still added new use cases in this abstraction. This whole idea of IDS IPS that Chris and Frank are going to talk about, that they inserted in NSX into the hypervisor, these are additional use cases in the virtual infrastructure that we didn't think about. So starting from consolidation, the abstraction allows us to do a lot more. And that's exactly what Service Mesh is doing. I started talking about the Service Mesh with the ability to do service-to-service communication, resiliency, and so on. But that's not where it's going to stop. Service Mesh is much wider than that. That's just the micro, very low-level Service Mesh understanding. So I'm focusing on one Service Mesh before we get to Tanzu Service Mesh, which is called Istio. I kind of explained there's different service meshes, but Istio is the most prominent one in the market today. And what you see is that it's very similar picture to what I showed. We have Service A. All the communication in Service A are going through the proxy. And I'll explain the next slide how does that work. And then proxies talk with proxies on layer 7 communication. That's kind of what the Service Mesh is. Basically, proxies talk with proxies. And the proxies take care of all the layer 7 communication, like encrypting the traffic, like getting information, observability stuff. So these are what the proxies are doing. But the interesting part is you add a control plane on top. Sound familiar? And now you got Istio. Very similarly, that we added control plane on top of the virtualization. We got virtual infrastructure. With Istio, we get the Istio Service Mesh. And the control plane, it's changing right now, to be honest, but the main components that you need to know about is a configuration component that sends configuration, the mixer that sends telemetry, and they're killing this part because it became a bottleneck. So what will happen in the next versions of Istio, the telemetry will be sent directly from the envoy. And also, and this is like the most important in my opinion, is Citadel. This is basically a CA, a certificate authority. And it can assign certificates to each one of these envoys. That means that each service that has an envoy has a unique identifier with a certificate that is managed by a CA that refreshes that for you. It makes sure that every service has a certificate. Now that every service has a certificate and it's handled automatically, I can create end-to-end encryption, MTLS, because they trust each other with the same CA. I can create authorization policies, like it's kind of micro-segmentation, but on layer 7, because it basically says this envoy can only talk with this envoy, but not with the other envoy. So it's very similar to microsegmentation. It's just on layer 7. So we don't talk IP to IP port like 5 tuple. We basically talk about business logic. Service A can only talk with service B, but not with service C. So this is Istio. So let's kind of, I hope kind of that made sense for you, what service mesh is, what the abstraction of service mesh is meant to do. I'm going to kind of now pivot into understanding how it looks in real world, the challenges with it, and then what does VMware trying to do here. And you guys know VMware is the abstraction company. We are the best in the market to be able to extract value from abstractions. I think there's no questions about it. And you'll see how we do that now for the multi-cloud, because if you think about customers that are operating different clouds, they need to operationalize that. And the clouds of today are like the hardware vendors of 20 years ago. They're very siloed. So we're trying to break those silos by virtualizing, abstracting more. But first, let's understand. So we talked about Service Mesh, and Service Mesh today is installed mainly on Kubernetes. Okay, that's where it's installed. But even if it goes on Kubernetes, meaning if I deploy microservices on my Kubernetes cluster and I install Service Mesh and I connect them, then you have inside the Kubernetes cluster, you're going to have service discovery, right? You have the ability for this service to find this service pretty easily. You're going to have observability. You're going to have the traffic management, right? To doing Canary upgrades and stuff like that. You're going to have all the service from stuff within the Kubernetes cluster. But here's the thing. Nobody stretches control plane across Kubernetes clusters. That means that nobody is able to stretch service mesh more than outside of the Kubernetes cluster. So if I have part of my application in one Kubernetes cluster and another part in another Kubernetes cluster, it's hard to get service mesh to work across these, especially if we're talking about across clouds. If I'm putting some of my application in Google because I want to use Google machine learning, and I use some of my application in Amazon because I want to use Amazon Web Services for another part of my application, and a lot of companies are now trying to get to what we call best of breed services, using the best service for their application in different clouds. How do I create a service mesh? It's hard because it's very siloed. The reason is, if you think about it, the use cases for breaking your application across is like what I said, best of breed services is for high availability. I may want to have part of my application here, another part for high availability purposes. I may want to separate different teams to different Kubernetes clusters to different clouds. I may want to have databases in one cloud and stateless in another, or and there's a lot of reasons. All these reasons require me to have independent Kubernetes clusters. Now I'll take it even further. What about VMs? Right? Not all the entire world is not Kubernetes. Honestly, the small amount of the world is Kubernetes. But I have services on virtual machines. How do I bridge that gap? That I have silos. Even if you're not operating multiple clouds, I still have silos because I have one Kubernetes cluster here, one Kubernetes cluster here. How do I create a service mesh that really branches that? That is what VMware is doing. We're taking the concept of service mesh and we're extending that beyond a single Kubernetes cluster, beyond a single public cloud or cloud, private, public, doesn't matter, and beyond just Kubernetes. We're taking it to virtual machines. So we want to allow our customers to have a real abstraction that is a service mesh that's across clouds, across Kubernetes, across workloads. I'm going to pause here for a second. Just want to kind of explain to you. I know you heard Tanzu Service Mesh, Tanzu this, Tanzu that. Let me give you kind of a 2 minutes about the Tanzu portfolio. We take the Tanzu portfolio and break it up to 3 main groups. There's the build, run, and manage. The build is all about, the builders, the developers. It's the stuff that developers can use, like Spring Cloud, .NET frameworks, Tanzu Application Service. If you ever heard of Pivotal Cloud Foundry, that's Tanzu Application Service. Tanzu Build Service, which is kind of something that Pivotal are creating now for Kubernetes, that they take from Tanzu Application Service. And Tanzu Application Catalog is Bitnami, right? Bitnami are the creators of a bunch of Helm. They created Helm project. They created a bunch of other V apps and all that stuff. That's Vietnam, right? So this is for the builders. The run is mainly the folks here on the call. This is the Tanzu Kubernetes grid, which is our Kubernetes, and PKS, which is another Kubernetes. VCF, VMC, public cloud, edge. This is the run part. The manage part is being able to manage and connect all these things together. So we got Wavefront, Tanzu Observability, it's called now. Tanzu Mission Control, which is basically managing multiple Kubernetes clusters. I won't get into that because of time. And then there's Tanzu Service Mesh. That fits in the manage part. So just wanted to kind of place it from the Tanzu portfolio for you where Tanzu Service Mesh live. And let's talk about the product. So if you remember, when I defined Service Mesh, the way the industry sees it in the beginning, I called it an abstraction layer between service to service. First thing we want to do at VMware is take the Service Mesh, principles of discovery, service discovery, visibility, like operational control, traffic, and security policies, and apply that not only to services, but to the entire transaction. Users that are accessing services, that are accessing data. So example being, if Chris here needs to access only the services in the US, I want to know about that. And if he needs to access only the data stores in the US, I want to know about that. And then if I can see it, I can apply policies like saying, Chris's group can only go into US services and US data stores. So VMware is taking the concept of service mesh and trying to extend it to the entire application transaction. And as I said already previously, we're taking it from Kubernetes. This is where we're starting, but it's going to be applied to virtual machines, public cloud, and SaaS and serverless. So VMware is well positioned to do this. The way that the product works is that we have kind of a global controller that currently lives in AWS. It's a service, you'll see it in my demo. And when you take a Kubernetes cluster, and doesn't matter which one, doesn't have to be a VMware Kubernetes cluster, it can be GKE, can be AKE, can be whatever, Kubernetes cluster, OpenShift, VMware Tanzu, right? We would install Istio on top of that cluster automatically. So you onboard that into my service, we'll install Istio for you. You don't need to install it for yourself. And we'll manage the Istio lifecycle for you, meaning upgrade and stuff like that. But we'll connect those Istio. This is vanilla Istio, but with additional capability to connect back to our service, to our service global controller. And now we create kind of a additional abstraction. So if you think about it, every Kubernetes cluster here has its own local abstraction with Service Mesh, but we are creating a top abstraction and we'll connect these together. I'll show you how we do that. It's pretty cool. We basically allows us to create an abstraction of the application, like an application slice that is across infrastructure. Now, I know it sounds maybe a bit, sci-fi. This stuff works, and I'll show it to you in a second. Now, the other question is, so we're doing Istio on containers, how planning to do virtual machines? So the first phase of adding virtual machines to the service mesh is using Avi Networks. I don't know if you heard of Avi Networks. I know Chris mentioned that in his session. Avi Networks is like top of the line load balancers. They do global load balancing. We bought that company a year ago. The best load balancer in the market. I won't get into too many details right now, but they have modern architecture with a control plane and the data plane, and they do global load balancing. They do analytics. They do a lot of really, really cool stuff. How does that relate to service mesh? If you think about it, if I have a load balancer like Avi, and I have a VIP, a virtual IP that is pointing to a server pool that is virtual machines, or even bare metal, or IaaS in AWS, whatever it is where Avi operates, that is basically a service, right? If I would have a bunch of VMs doing something, that's a service type VM. Now, if I can take that VIP information from Avi and replicate that into my service mesh, my containers on Kubernetes can find those VMs part of my service mesh. Now, those VMs are service discovered. I can encrypt traffic. I can provide them with traffic control. I can extend into, because Avi is basically acting as a proxy, just like Istio Envoy is acting as a proxy in Kubernetes. Hope that makes sense on how we're going to bring VMs now. We're not there yet, working on the integration, but I believe we're going to be the first vendor to actually bring VMs into Service Mesh. It's not going to be only a Kubernetes thing, because Avi already created their own Service Mesh before we bought them. We just need to integrate those. Now, before I get into a demo, there's one concept I want to explain that is hugely important to understand on Tanzu Service Mesh. It's called the global namespace. Now, namespace in Linux or in Kubernetes is basically a logical container. It's a tenant. We took that and we kind of extended that notion into our service mesh. And what we do, check out this screen. You got Kubernetes clusters in different clouds. One VMware, one AWS, one Azure, one Google Cloud, whatever, right? And I may have parts of my application running in each one of these clouds. I may have the purple running in VMware, and the green running in AWS, and the blue running in Azure. Now, I create in my service a global namespace, and I add those services in to my global namespace and say, this is an application. Now, once I did that, I can create a DNS record for each one of those with the domain name of my global namespace and plumb that into the DNS of the Kubernetes on each one of these clusters. So when purple needs to find green, purple runs here, green runs here, I don't need to specify ingress points, IPs of AWS, where the service lives. I plumbed all this DNS information down for the developer. It doesn't need to do anything. All it needs to do is call from purple to green.acme.com. It will get to it. So we kind of managing all the plumbing down into all the service meshes. We're kind of creating a service mesh of service meshes, right? We're abstracting all the DNS naming down into them. And this DNS can be also a subdomain of the corporate domain that you have. So you just point to it, and then all these clouds, the containers on them will be able to find each other. Now, remember I told you each Istio has a CA that gives certificates, and they now pods trust each other. They can do encryption. So what we do, we kind of augmented that. We created our top CA in the global namespace, and we created the local CA on each one of these Kubernetes clusters as a subordinate CA to that top CA. So now the pod purple here trusts pod green here, and I can create end-to-end encryption. So all the traffic is going to be encrypted out of the box. And then we can apply policies like green can only talk with purple, purple can only talk with green can only talk with blue. We can create traffic routing saying send traffic to version 1 to version 2. We can now control on the global namespace. We do a top service mesh slice of it, and then basically abstracting the application. I want you to think a bit forward, okay? Think about firewalls. When you do firewall today, you have zones. If you're doing distributed firewall with NSX, you're now doing microsegmentation. But what happens when you now branch out of your site? You branch out to multiple sites, to multiple clouds. I have a lot of infrastructure stuff that I need to automate. So with this, I can create an abstraction of an application and apply policies from the top and enforce them in different enforcement points. So looking to the future, this global namespace can be a really good way to abstract stuff across infrastructures. So that's kind of the future. All right. That is kind of on the product. I'm going to go into the demo. I just want to pause here and see if there's questions. So please feel free to ask any questions. You guys can hear me, right? Okay, cool. Questions? There's no questions?
Bueller?
Can you hear me?
Yeah, we can hear you, Niran.
Okay, cool. All right. Did I lose everybody? Was I like going? Okay, cool. So let's move on. Demo. Let me show you. Let me show you the product. I mean, that was kind of an academic view of things. I'm going to start from the end. This is my global namespace. What I have here is an application. Actually, let me do this here. I wanted to do something specific. There's a hidden menu here. There you go. Let me refresh this. All right, let's set it up so it's easy to see. So this is what I have here. I'll show you. I have an application, and I'm going here. This is the application. It's called Acme Fitness. Acme Fitness is a full microservices application. So everything you see here is a microservice. This front end is called shopping. It's the front end, the web server, right? And then I have a catalog. You see these pictures here? They come from the catalog. The catalog is a different microservice with its own database. And I got also, the cart. The cart is another microservice. And I got a login here for users. That's another microservice. So everything is microservices. And this is, by the way, this is available on the internet. This is open. We use this for testing and stuff like that. You can go ahead and use it yourself. Just look for Acme Fitness VMware. You'll find the GitHub. You can deploy it on your own Kubernetes. It's pretty cool. I ran 2 instances of this application. One local, one in Amazon. You can see that. And I'm sending traffic to them so you can see the traffic in my service mesh. I'm going to jump back and forth, just showing you the application. Going back to here. This is what you saw, this is the application. Now what you saw there is this. This is the on-prem TKG. This is my Kubernetes cluster on premises. And my front end, my shopping is running here. But all the backend services, see the cart, the catalog, the order. Sorry, this is something in the UI that we need to fix. But all of these services are running on the backend here. They're running in the cloud in EKS. So this is Amazon. Also, I put another front end in EKS for high availability, and I put a load balancer sending traffic to those 2. So if one fails, it sends to the other. Now, the first cool part here that you see is that everything you see here has a service discovery. So shopping can find order, this service can find this service by the domain name I gave to this global namespace. And you can see, I'll go to the global namespace here just to the definition. You see how I created it. It's pretty easy. It's really not hard. I just said acme.local is the domain name. Let me show you how it looks in Kubernetes. I'm sorry for the console. Can you guys now see what I'm seeing? You see the screen here?
Is it just me? But it's like broken up in the audio.
Yeah, you're breaking up a bit, Niran. I wasn't sure if it was my connection or what, but your audio is breaking up a little bit.
Was it breaking up the entire time? You guys didn't?
Yeah, now it sounds proper. So whatever it was like very broken up, staticky.
It's better now.
Okay. I hope you guys heard like.
No, you could hear it. You could hear it all. Yeah, it was just had these overtones that were going in and out of your.
I'm like, I'm talking. And nobody can hear me. So here's the cool part, right? I have let's see. I have here. Oops, I have a few Kubernetes. So no, actually, this is what I want to do. This one. Let's come on. So you can see this cluster here, TKGI1. You see this cluster, Kubernetes cluster that I'm running on here. I'm going to jump back here, and you'll see this is exactly this guy here. So going back to this view, I'm going to just make it look better. You see this cluster here. This is TKGI here. So you see I have one service here called shopping. Going back here, if I do kubectl get pod, you see that I got shopping running here, right? If I look at the DNS records on this cluster, kubectl get service entries, it's basically DNS. You see that all the DNS records have the acme.local. So all the services are discoverable by the domain name I gave to the global namespace. If I kind of drill down into this DNS record, it's called kubectl edit service entry, and I just take, let's say, order. the name here. It shows me the DNS record. It says basically to get to this service, you got to go to Amazon, right? Through this API. So I plumbed down, when I created GNS, it plumbed down the DNS records in all these clusters, and shopping finds the order, not by the IP. I know as a developer, I don't know all these ingress details, how to get to a service. I just say order.acme.local, and I get to it because I plumbed down DNS to all these clusters. If you see, I'll jump to another cluster, you'll see that it's exactly the same. Right now on TGGI, I'll go to the EKS one. This is EKS and do exactly the same. Service entries. You see that all the service entries in a second. It's because it's Amazon. It takes me a bit longer, I guess. There you go. See that all the DNS are exactly the same. So we plan down the DNS records for the entire thing. Now, I want to check to see if everything is encrypted. It's really hard to get encryption going, right? So I can do encryption. I get encryption out of the box just by putting stuff in my global namespace. Look at this. I'm going now back here, and I'll do, let me just, there's a command just to see if stuff is encrypted. This is the command, so I'm taking it. And when I'm telling it, I'm saying still control TLS check for MTLS from shopping. This is the shopping pod. Let's say to order.acme.local. So I don't call out the container by its ingress name, again, only by the domain name. When I do that, it tells me, hey, this is encrypted. So what you see in here, all these lines, everything is encrypted. And I'm not using any gateways, any VPNs, anything. Cross-cloud encryption, cross-cloud discovery on the application level, without regards to what they're running on. This is what Service Mesh is all about, just broken from a silo to across clouds, and soon also across workloads. And there's a bunch of other things. I'm just going to show you quickly. You see these lines, they show requests per second. I can actually troubleshoot stuff. Because if I have a problem with latency and cascading effect and stuff like that, it's really hard to understand what depends on what. I'm going to make this bigger and see everybody. It's really hard to understand what depends on what. So first of all, we see here is the dependencies between the services. We see that these services depend on shopping. We see the traffic direction. We see this traffic goes with this arrow here. This traffic goes here, and so on. We see the request per second. And if I hover over any of these services, I get how many requests per second, what's the latency right now, and how many errors. These are important things to know. If I go here back to my home, I can see the clusters here. I can click into them. Again, I can see the dependencies between the services. But if I click into any of the services, I can also correlate the information from the service to the nodes they're running on, the CPU utilization, the memory utilization nodes. I can see a lot of stuff already here. And there's a bunch of other things that this will do, but just wanted to show you that we abstracted the application out from the infrastructure. We made Service Mesh something that's usable for us. I hope this helps and makes sense to understand better what it's all about, and you understand what Service Mesh is, what VMware Tanzu Service Mesh is, and if you have any questions or whatever you want to learn more, just hit me up, and I'll be happy to help. I'll open it up to questions. We still have everybody?
Anyone?
I think it's a lot to take in the beginning, so I think the questions kind of come out as you process it. Because even me right now, I'm taking all that in.
Niran,
what would I even ask?
There's a question in the chat where people can go to learn more.
All right. So a couple of things. One, I'm going to post in the chat. I'll find it. We wrote a book Service Mesh for Dummies book. It's not even about our product. It's just a small part of it. It's just Service Mesh for Dummies. I'm gonna put the link in the chat so you guys can download that and just read and understand a bit better about Service Mesh. There's also, I'm gonna put in the chat in a second, a demo, an 18 minutes demo of the demo I just created. It takes it slower and goes through the onboarding process and showing how we build stuff. But end of the day, guys, it's pretty easy to understand. Abstracting the application from any underlying infrastructure, creating encryption between those components, allowing the services to discover each other so developers don't need to do any infrastructure stuff. And then we're going to apply on that security policies, we're going to add VMs. This is not rocket science. This is like basic, how do we make stuff work together across clouds or even across just Kubernetes clusters or workload types. Cool. And security is huge here. We haven't implemented security yet, but we're going to have a security policy that doesn't care what you're running on. It will be able to apply security policies from the top down on anything human readable. Instead of saying 5-tuple, IP, port, you'll be able to say Ben can access only US services, can only access data stores from the US, and understand that. It doesn't matter if you run on Amazon, on Azure, on VMware, it would work. Hope that helps.
Good stuff. Thanks, Niran. Yes, sir. All right. We're running a little early. We're running a little ahead of schedule. So, Yury, are you ready to go, or do you need? Do you want us to take another break and come back when you're ready?
Yeah, let's do a break and then I'll go. Do a 10-minute break.
Okay. We'll take another 10-minute break, guys. Feel free to use the restroom, get a drink, get coffee, put on pants, whatever. And again, please fill out the, I'll post again in the chat, give me a second, the link to sign in for today. I created a Google form just to help keep track of who's attending and who isn't. So please fill that out, and feel free to turn your cameras on if we can see everybody. VMUG is a social experience. We get to see each other in person. Since we can't really do that right now, let's see each other's faces through Zoom. So all right, we'll come back in 10 minutes, around 11:20 or so. And we can, we'll get going again. Thanks, guys.
Hey Frank, what is that in the background?
Yes.
What you got there?
Star Wars.
What's that?
Oh, Star Wars. Got it.
Yeah, there's a ton of them they just released last week. There's some good ones.
I didn't recognize that scene. Where is that from? Is that like the Rebels?
Yes.
Quarters? Yeah, okay.
Nice. Hey, Chris, what's your background? Is that Tony Stark's lab or something?
It is.
Nice.
I'm you know, you talk superheroes, it's so funny. I'm backwards. I'm a Tony Stark fan. So
Nothing wrong with that.
no, initially I mean, like I even labeled it my dream garage. Like if you ever had money that you didn't know what to do with, I would probably have an office right in the garage with probably the best sports cars you could ever imagine, and that was probably about as close as. Oh, actually, no, I have another image. I'll show you while we wait. uh, if well, it'll never happen, but you know what I mean.
Nice. Nice.
So
It may happen if the augmented reality capabilities from here are going to evolve, or maybe.
yeah, if I had a hand in it.
Now, what I'm saying is, we could augment reality for you.
Oh yeah, right. Or the like downsizing, right? That movie Downsizing.
Oh shit! Hold on.
That's funny. You know, you always miss the office presence, being able to shake people's hands and things, but it is pretty cool that we could all meet, see each other, and do some, have some fun backgrounds. It's pretty cool. The timing was right for that.
Yeah. Yeah, definitely. I hope to do some more of these later in the year.
Awesome. I can't wait for the day that they get Zoom to be able to have well, they already have a whiteboard, but I want the whiteboard to be able to present behind you. So if you're drawing out your presentation, you can come up behind you. That would be really cool.
That'd be cool, yeah. Especially if you're drawing it on a tablet and it shows on the screen behind you.
Behind you, yeah, exactly. Someday.
Yeah, that'd be pretty cool. Hey, Mark, I like your background.
Hey, you like that? I'm on the Millennium Falcon.
Very nice.
I was actually trying to find a good one from Spaceballs.
Oh, yeah.
It's so funny because if you don't have people in it, it just looks like Star Wars.
Exactly.
Yeah. Just a Winnebago, maybe.
There you go, the space bus. Got to work on that.
Yeah, we actually use Zoom corporate wise. I implemented Zoom 3 years ago with our company, and it's amazing the progress that they've gone over 3 years, how they've grown.
Yeah. Especially recently with the changes that had to be implemented with everything going on with COVID and the hackers getting in randomly, so they had to implement. My company required the use of passwords for all meetings because of that, and yeah.
Yeah, that was the same with us. I mean, we always use passwords. Like I set it up because there's tons of settings within the settings console where we mandated passwords and stuff, and that's kind of where the Zoom buying stuff came in, right? People were doing it without passwords and things. But most recently now is they upgraded the encryption and everything again with version 5.0, which is happening end of this month. And then I think we have about 720 maybe installs on all of our clients, because we have the Pro series. We have like 250 license, and then all the rest everybody has installed with just the basic. But at least we have that full functionality of meetings up to 40 minutes with the basic, and then managers and above, they have the Pro license series.
Gotcha. Nice. Yeah. With all this happening, VMUG headquarters went and gave us this a license for different VMUGs could request a Zoom license to use. So, but I use one for work as well as WebEx also. So
cool.
They're both pretty similar.
Yeah.
Yeah. All right. For anyone that might have joined late, I posted a link in the chat to please fill out for attendance for today, just to be able to keep track and let VMUG headquarters know who's attending events versus who's not, whose accounts are active and who's not, and so on. So with that, Yury, are you ready to go, or do you still need a few more minutes?
I am ready to go. I don't know what's up with my video. 1 second here.
It was there before.
Yeah, I know it was there before.
Yeah.
Yeah, 1 second here. Let me just. Let me see if I can. Fix my video. You know what? I'm gonna get out of the Zoom and get back in. I just think that something happened to my video and it just needs to reset the Zoom.
No worries.
Just 1 second here.
I hope everyone's staying safe and well doing all this. Finding ways to work from home and hopefully and find toilet paper.
Yeah. For any Big Bang Theory fans, remember when Sheldon tried his virtual presence where he had the robot going out to do things for him? Talking to my wife, I said I should kind of have something that looks like Short Circuit with a with a shirt hanging.
Yeah, Short Circuit number 5 is alive. Nice. So while we're waiting for Yury to come back on, what does everyone think about having events like this again in the future? Feel free to unmute yourself and we can have a conversation. An event that I've wanted to put together for something in person for a while that I think might be good for us to do virtually would be an event focused on professional development. My vision is to have a recruiter come on and talk about the importance or talk about resume writing skills and job search and stuff like that, and have maybe someone from VMware Education come on and talk about the importance of training and certification and things like that. I think that from talking to different people at events, I think that there's plenty of people out there that are either looking for a job or not happy in their current job, but don't know where to get started to move on. And I think having an event like that might help give people the push they need to move forward, either in their career or in their current job or to a new job.
A great idea. Just even the thought process of where to start and what are people looking for these days and all that. That's a great topic.
Yeah.
Yeah, Ben, good to have VMware Education, because as you probably are seeing, we're changing our certification model a little bit different. So it'd be good to give an update on how
that'd be cool. Yeah.
How it'll be changing in the future. As you know, everyone knows that we can all the VCP exams and some of the advanced ones you could take at home now.
Yes, I saw that. Yeah, I spoke with I forget his name, one of the guys from VMware Education at the New York, New Jersey VMUG UserCon last year, and I have his card. I just need to dig it out and reach out to try to schedule an event later this year. Awesome. Welcome back, Yury.
Thank you.
We can see you now.
Sorry, I had to restart my laptop for some reason.
That's okay. You ready to get going? Awesome.
Okay, Ben, you see my screen?
Yes, sir. You're good to go. Thank you.
Okay. Thank you. So my name is Yury Magalif. My session is Horizon 7 Disaster Recovery. It's a very, very relevant topic nowadays because due to coronavirus, obviously everybody is using VDI. Every year they keep saying, oh, it's the year of VDI, it's the year of VDI. And me being in VDI, I always think, well, maybe this year. And it looks like it's going, and then it kind of plateaus. It's been like that for the last, 20 years. Well, this year, it's very unfortunate that, it's because of the virus, but this year, again, everybody's saying the year of VDI, but I have, you know, twice as much work as before, which is very fortunate. But it looks like just everybody is using VDI. Everybody wants to use VDI. I have a client that comes in and says, I want, you know, 300 desktops deployed in a week, okay, because I don't have a way of remote access. So I have people expanding, you know, their capacity immediately for VDI. So I think finally this year, VDI is made it. And hopefully after the virus, it's going to keep going that way, okay? So of course, you know, now that you have VDI and you're looking for VDI, how do you protect it, okay? You must have high availability, especially now that everybody's working from home, and you must have some sort of disaster recovery, because you need to do, you know, disaster recovery tests for compliance, and you need to be able to do that. So how do you do disaster recovery for Horizon, for VMware? So the agenda is we're going to talk about different types of desktops and how to do disaster recover for each one. High availability in DR for non-persistent, okay, the more expensive design, but the more ideal design. Then disaster recovery for non-persistent and persistent dedicated link and instant clones, a cheaper design. Then we're going to talk about disaster recovery for persistent dedicated desktops with full clones. Then we're going to talk about a couple of scripts that can be used in a persistent and dedicated design. Then, of course, about user data profiles and applications. How do you deal with those? We're going to finish up with disaster recovery for VMware Identity Manager, or Workspace ONE Access, it's now called. And then some general high availability tips for your Horizon 7 implementation right now during coronavirus, okay? Okay, so the first design I'm going to talk about is the so-called, you know, ideal design for high availability and disaster recovery for VDI. That is, we want to have you know, two sites, production and DR, and we want to have them in an active fashion, okay? So that if a user is getting a desktop from one site, site A, and that site goes down, the user gets immediately a desktop from site B, right? And we want to achieve an RTO here, last item here, RTO of, you know, a minute and RPO of 0. So how do we do this, right? Well, first of all, you need to have at least two sites that have appropriate capacity to be able to handle all of your virtual desktops, okay? Large enterprises can handle it no problem, all right? Your Fortune 500s. Mid-sized enterprises can sometimes handle it, and small businesses cannot handle this design because it's too expensive to maintain double the amount of capacity in both sites, okay? That's what I'm saying. It's an ideal design, but it's expensive. So once you have the appropriate capacity, hardware capacity in both sites, you also want to have good load balancers. And you want to place your load balancers in front of your unified access gateways or the old security servers if you still have them, okay? So that when external users try to connect, they connect to a load balancer, which balances between a couple of unified access gateways in case one goes down. And then you want to also have load balancers in front of your connection servers. Now sometimes this could be the same load balancers depending on how you configure load balancers, or it could be 2 sets of load balancers. And of course, with load balancers, you want to have, most out there can have 2 nodes. So you want to have 2 nodes at least for load balancers. And so essentially in that design in one site, you're going to have 2 load balancers for external connections, 2 load balancers for internal connections. So 4 load balancers. And then in the secondary or site B or DR site, you're also going to have 4 load balancers. So you can see that, for example, if you were to buy F5s, so you're going to have 8 F5s in both sites. So it quickly starts to become expensive for small businesses, right? Once you have the load balancers, you want to create a Horizon 7 site or pod in your primary site, and you want to have a pod in the secondary site. And then you want to use Cloud Pod, which is a technology that connects the 2 sites together so they know about each other in a federated fashion, right? So the connection is not, they don't see 100% everything, but they see enough to be able to accomplish failover, okay? So once you have Cloud Pod enabled, and you see everything in the same console, you see both sites in the same console, you want to make sure that you use, in this design, preferably non-persistent or floating desktops, right? So this design works best with non-persistent desktops, okay? Why is that? Because if a desktop is served from site A, right, and site A dies, right, you want to have a desktop from site B, but you want to have a non-persistent desktop that doesn't have any user information on it, right? That is completely fresh. That way, it doesn't matter where the desktop is coming from, site A or site B, because there's no user-specific information on it. It can be coming from either site. That's why it's important to have non-persistent or floating. That actually also poses a problem for smaller businesses, because achieving fully non-persistent or floating desktop architecture is more difficult than having persistent desktops, okay? You need to put a lot more effort in order to make sure that your user profile is outside your desktop, that your applications are outside your desktop as much as possible, and your user data is outside your desktop, okay? And that takes a lot of work, all right? That's so in this design, you want to maintain a pool of non-persistent desktops, a local pool in Horizon speak, in site A and site B. And you want to make sure that the parent image for those non-persistent desktop is the same in both sites, okay? Can you do persistent desktops in this design? Yes, you can. Again, and this is not the ideal situation. Yes, you can still have persistent desktops, but of course, persistent desktops are only going to exist in one site. So if your user has a desktop in the primary site, and that site fails, the user no longer has a desktop, okay? That's why persistent desktops in this design are not ideal, but you can still do them, okay? And you can add persistent pools, and you can mix and match. You can have some non-persistent desktop pools, and you can have some persistent desktop pools. If you accomplish this design, you can have a recovery time objective of a minute, basically, or even less. Essentially, if the site dies, the load balancer decides, oh, the site is not available, and the load balancer switches you over to the secondary site, right? In the load balancer, you got to make sure you have geographically distributed load balancing, right? GSLB or DNS load balancing. So the load balancer can balance between the 2 sites. And most advanced load balancers can do that. However, again, that's usually an extra license for load balancer. So again, this becomes more expensive. So this is a general picture of how this design works. What you see in here is side A, and on the left with pod 1. And you can see in here that in this particular side A, there's actually 2 blocks of Horizon users. Okay, there's a separate vCenter for each one and a separate desktop pool for each one. So this is kind of a mid-size enterprise diagram, and essentially, there is a load balancer inside A, which is not shown here, but there's a load balancer. And so, for example, if something happens in the first block on the left, the load balancer will switch the user to the second block on the right. Okay, in pod 1. And since the desktops are all non-persistent, it doesn't matter, right? And then you could see at the bottom, it says global data layer. By that, we mean a global load balancer, okay? When the users connect, and let's say side A is not available, the global load balancer will switch to side B, okay? And the same thing, there's two blocks here in side B, and high availability within the site. The one interesting thing is that, for example, let's say we have a user that is physically located in side A, right? And the user connects to the global load balancer. Well, we want that user to be able to go to the site where he's located, so that latency is best, right? Lowest latency, and everything is close by. All the desktops are close by. You can do that with CloudPod by designating a home site. So a particular user group in Active Directory has a specific site as a preferred site. So the users will always be sent to that preferred site unless that site is not available. Then the user will be sent to the secondary site. Okay. The one interesting thing is that in the CloudPod architecture is that, let's say a user has a desktop in side A, right? But the user is physically in side B, right? So when a user connects to a load balancer, the load balancer normally, if you just configure the defaults, is not going to know, where necessarily to send the user. It's just gonna by default just gonna randomly assign a user to a pod. And let's say the user is assigned to side B, right? But the desktop is in side A. So once the load balancer passes the connection off to the CloudPod, and you can see in here there's interpod communication here right between. So the CloudPod, which works on top of all the connection servers, is going to decide, oh, you know what? The user is coming through side B, but actually has a desktop in side A. So let me actually route the user over to side A. However, what happens is that the connection goes through the data center link between the sites. Okay. So essentially, the desktop is served on the data center link between the sites, which means that you need to have a nice beefy data center link, because users that are not on the correct site are going to be served desktops over that, right? Yeah, so CloudPod is not, smart enough yet to have the user connect in the proper location, right, and not go over the data center link. So that's the CloudPod architecture. And this is the holy grail. This is what we want to achieve as much as possible in the VDI world. However, it's not always possible, right? So what's the alternative? The alternative is that we can have a not high availability, more disaster recovery architecture between the two sites, but we're going to make it a bit cheaper, right? How do we make it cheaper? Well, first of all, we are not going to have an active setup, right? We're going to have an active standby setup. That's the first thing that's going to be cheaper. So what that means is that in the DR site, you can have the same capacity if you want, or you can have less of a capacity, right? And then you can only protect specific desktop pools. So you can save money and capacity in the DR site, okay? Also, in that design, the load balancers, you're not required to have a load balancer that has a GSLB, between the two sites, okay? You can just have a manual DNS name, let's say, VDI site 1 for site 1 and VDI site 2 for site 2, right? And in case of a disaster, you just give your users a different name to connect to, all right, manually. So that way you save on load balancers, on advanced load balancers, all right? So how do you achieve this? How do you achieve this architecture, right? Well, you build a Horizon infrastructure, the connection servers and the UAGs and everything in the production primary site. You build the exact same Horizon infrastructure in the secondary site. So infrastructure-wise, usually you want to have the same infrastructure, okay? And by infrastructure, I mean the Horizon virtual servers, right? Connection server, UAG, not necessarily hardware. Hardware, you can have less in the DR site if you want. So once you build the exact same infrastructure in both sites, you then build the exact same pools in both sites. That's if you want to fail over everything exactly as is and you have enough capacity. Or you can have only certain pools fail over. And as a result, hardware-wise, you need less capacity, right? Then you still need to have a replication of some sort, right? And by that I mean storage array replication, between the two storage arrays in two sites, by LAN or by volume, or like host-based replication like Zerto, right? Or vSphere replication, right? And you want to make sure that that's configured, and then it's configured for standard failover from one side to the other. And then you create non-persistent or floating desktops if you want to do those, okay, in your primary site. And you create them using link clones or instant clones. And then you take the parent and our golden master image, and you replicate using your storage replication or host-based replication. Or you can even use VMware Site Recovery Manager for that, right? If you have that set up. And you can replicate that parent image over to the secondary or DR site, okay? If you have a disaster and you need to fail over, what happens is you initiate your failover using your storage array application or SRM or Zerto or something like that, right? You initiate the failover. It fails over the parent image. So now the parent image appears on the DR site, right? But at this point, there's no desktops in DR site. There's just the parent image. At this point, you go into the exact same pools you configured on the DR site, and you specify that parent image. And by the way, the pool settings, you want them to be exactly the same as in the production site. Then you go in the pools, and you specify the failed over parent image as the as the source, and then you recompose the pools in the DR site and generate all your desktops. Okay. Once your desktops are generated now from that image, you're back in business. You know, you could tell the users, you connect to my, you know, VDI site2.company.com URL, and you're back in business. How long does that RTO take? Well, it really depends on how many desktops you have. Okay. You know, I say here RTO of 1 to 8 hours. You know, so if you have if you have 10 desktops, that procedure will take you, you know, 30 minutes, right? You know, but if you have a lot of desktops, you need to allow time not only to do this failover procedure yourself, right? Which is, you know, a bit manual, okay? But also then you have to wait for generation of desktops, right? So yeah, it could take you the whole weekend if you have, you know, link clones, and if you have you know, more than 1,000 machines, right? The RPO for this is going to depend on your replication tool settings, which nowadays most of them can do, you know, I think the lowest for some is 15 minutes. Some can do less, some can do every hour replication. But the point is that, you know, you're probably going to lose no more than 15 minutes of data. So this is with non-persistent desktops, but you can also do this with persistent dedicated desktops that are link clones, right? Now, that is the persistent dedicated link clones desktops are probably not the most ideal config, but I still see a lot of it out there. You know, as a result, a lot of my customers ask me, you know, how do I fail it over? So the thing to remember if you're using persistent or dedicated link clones in this design is that, you know, once you fail over to the DR site, if users installed anything in these persistent or dedicated desktops, you know, all of that will be gone because the desktop will go back to the last time that you created the image. Okay, so you just have to be aware of that. You know, if you're using non-persistent floating desktops, you know that everything is gone when the user logs out, right? The desktop is destroyed. So everybody's used to that. But when you're using persistent/dedicated with link clones, a lot of times I see users are used to installing things in their machine, you know, storing files in their machine, and all of that will be gone if you fail over in this scenario, right? So something to be aware of, right? All right, so here is a picture that represents this design. All right. So notice, you know, we're not showing load balancers here. Okay. You know, in this design, you may have a load balancer, you know, in the specific site, right, in your production site, and maybe your load balancer a local load balancer for site 2, but usually, you know, you're not having a global load balancer in this design. Okay. So you could see in site 1, you have your, in the middle here, you have your master VM or parent VM or golden VM image, okay, and that's what the desktops are generated from in site 1, and then you are replicating that. You can see here in red, you're replicating that master image using your replication tool of choice to the secondary site. Okay, and in the secondary site, you can see that all infrastructure is also here. And by the way, in all of these designs that I'm talking about, you should make sure that the Active Directory domain controller is available in the secondary site. So all designs require an Active Directory domain controller in the secondary site, right? Do not use replication methodologies to fail over your domain controllers, right? You should have a full-blown production domain controller in your secondary or DR site, and it should be doing domain controller replication with the rest of your domain controllers. That's an absolute requirement. So just keep that in mind. But anyway, going back to this, so the master VM or parent VM is replicated. Okay. Once it's replicated to secondary site, you're generating the desktops from it in the secondary site. All right. In this diagram, you also see how to recover apps and profiles, but I will talk about that in a little bit later. So we talked about our ideal design with non-persistent desktops and load balancers everywhere and Cloud Pod. We talked about the the less ideal design but cheaper, where we don't have Cloud Pod. We have two separate sites built out. One is an active, one is a standby. But what do you do if you have full clones? Okay, you have full VMs that are persistent, right? They're not using any kind of space saving or image generating functionality, right? What do you do with that? And there's a lot of customers that have just your basic VMs or as desktops. Okay, most of them that I see have them as persistent, dedicated, full clones with automatic assignment, right? There are some that have manual assignment, but that's pretty rare. Okay. So what do you do? What do you do with those? Okay. Well, the way to recover those is, again, you're going to have an active and standby design. You're going to have a Horizon infrastructure built in your primary site, and you want to build the exact same Horizon infrastructure in your secondary site. Okay. Again, because chances are you're not going to have a global load balancer, you're going to have two different names that people need to access. So in the DR situation, you give people a second name, VDI site2.company.com to access. You want to build the exact same pools in both sites with the exact same settings, right? And by the way, this design, there is no Cloud Pod, right? You're not enabling it. You're not connecting the two sites. Okay. Can you do that? You can, but I see a lot of customers just don't want to do Cloud Pod yet. You just want to have two separate sites, and that's how they want to do things. So there's still a lot of those implementations remaining. So anyway, you build the exact same pools in both sites. When you build the pools in the GR site, what's going to happen is Horizon doesn't let you create a pool unless there is at least one VM in it. So in the DR side, you can create, one dummy VM, and when you create the pool, you add that VM to it, right? And then once you create the pool, you can remove that VM, right? And the pool could just be sitting there idle with no VMs, right? Then you also use replication technology of choice, storage arrays or volume or host-based replication like Zerto. The one thing with host-based replication like Zerto in this situation is that it can get pretty expensive, because usually host-based replication, if you buy a third party, is charges you by VM. So if you have 100 desktops, they're going to charge you for each desktop separately, right? Whereas if you use storage array-based replication, you have two storage arrays, it replicates the whole LUN, all your desktops are on that LUN. Okay, so you can also use SRM to if you have that site recovery manager from VMware, if you have that set up, and fail over those VMs using SRM. Okay. In addition to that, in order to make sure that this is more automated, there's some manual stuff in here. but we want to make sure the things that increase our RTO are automated as much as possible. So you're going to need to have custom scripts. Okay. What I usually have two scripts. I have a script that pulls the current VM user data from production on a regular basis, okay, and stores it in the DR site. So I know exactly, what changes were happening and which users are assigned to which desktops. And because remember, the production and the DR are two separate Horizon builds, right? They don't know about each other, okay? So anyway, so I have that script that pulls data from prod about user mappings to machines. And then I have a failover script that I run when there's a disaster or when there's DR testing, okay? And in this design, you can accomplish a recovery time objective of anywhere between 1 to 4 hours, right? Again, it depends on your storage replication tool, right? How fast it can fill over things. Usually, if all your VMs are there, it can fill over things pretty quickly, all your VMs, and so if you have a nice run book set up, you can accomplish this. You practice. You can accomplish this process in an hour. Okay. If you have to fumble a little bit here and there, it might take you up to 4 hours approximately. Okay. The RPO is, again, depends on your replication tool, and it's going to be around 15 minutes. Usually, most tools do that. Okay. So what happens in this design is if there's a disaster, right? You go to your DR site and you check, you make sure your script is pulling the data correctly, right? It should have pulled the data the first script every day, and then you run the second script. Usually all your variables are already entered. If not, you adjust the variables in the script, and then you run the second script. Okay. Here's a description of the script. The user data script is using PowerShell commandlets that are available for Horizon. You set it to run in the machine in the GR site. Okay, make sure it's the GR site, and you can use a Horizon read-only account. Make sure you lock it down because I'm storing the password in that script in clear text. When you write that script, the standard CSV export commands and Horizon PowerShell modules, they sometimes miss things like, they would miss like which user is assigned to which machine, and it kind of happens randomly. I guess there's some bugs in them or something. So what I tend to use is a kind of a general get HV machine summary export command, which just exports kind of a general screen where there's machines and the users and what pools they're assigned to and what data stores they're using. So I just get that general output, and then I massage it so that only the machine name, the pool name, and the username are left in the resulting CSV. Okay. So this script runs once a day on a machine and pulls out that data, right? So if you do a change a day, for users assigning machines here and there and unassigning, the script will pick it up, right? Usually once a day is fine. Okay. When you set up PowerShell and you want to make sure you have the latest version of PowerShell, you want to make sure you have the latest version of Power CLI, and you're also going to need to get the VMware HV helper module, right? And that is available on GitHub, okay? And that is essentially it's kind of a half VMware, half community effort. There's a lot of code from VMware in there, which that code is not, fully debugged. So there's some bugs in it, but it is very useful. And there are some commandlets that the community wrote that are very useful. Okay. So the second script that you want to use is the failover script, right? And in the failover script, you want to make sure in PowerShell you declare parameters to reserve memory. It's just makes things faster. You also want to make sure that anytime that you change or add data stores or LUNs in your production site for your storage array, right? That you or port groups in your production site, you want to make sure that you have adjusted this script to add those new LUNs and port group mappings. Okay, so essentially, what I tell customers is make sure you put in your procedure, your standard operating procedure, that anytime you add those LUNs or port groups, you have to go to the script and you add those things in there. Okay, so that they're available in case of disaster, right? Then in the script, once you run the script, you import a CSV file that the other script created that runs on a regular basis, right? You import that file, and there's a desktop to pool to user mapping in there, right? So this is during disaster. In case you want to do DR tests with some test machines, what I usually do is just create that CSV file, and I just put manually, a few machines in there. Because the way the script is written, only the VMs that are in that CSV file are going to be affected. All right, it's not going to be the whole data stores that are replicated. It's not going to be all VMs. It's only the VMs in this CSV file, right? So if you only put like, a few VMs to test out your DR, that's what you're going to fail over, right? If you have a disaster, of course, you go to the DR site and you just run the script, right? If you're doing DR tests, then in the script, what it's going to do is it's going to look at the desktops in the CSV, and it's going to remove those desktops from production and shut them off in vCenter, right? Why? Because you don't want the same desktops, with the same Active Directory profile suddenly appearing in DR. Active Directory doesn't like that, right? So this is for DR tests. But if you're in an actual disaster, when you run the script, that portion is just going to error out, and it's I have the help in there in the script. They'll just tell you, don't worry about that, okay? During a disaster. The failover for the script, depending on what storage array you have, some storage arrays will allow you to use storage array commands and put them in the script. For example, I worked with Rob Girard on the script for Tintry storage boxes, and Tintry has a nice interface where you can just use PowerShell commands and it will do the failover right in the script. So I have a script specifically for Tintry where the command's already in the script, and you just have to run the script and not even go to the Tintry interface. It will just fail over, right, automatically. But there's going to be some other storage arrays which don't have as good of PowerShell commandlets, right? For example, another one of my customers is using EMC's Extreme IO. Extreme IO is a great box. I love it. But the PowerShell commandlets for it are not as good. There's just API, so it's not easy to write that portion. So for that particular array, right, I just have in the runbook. So I go over to the array and just manually fail it over. It literally takes 5 minutes to go over and click a few buttons to fail over your volumes. Okay, but whichever way you do this, in a script or not, but the point is that once you do the failover on the storage array side, or on the host-based replication side like Zerto, your VMs are going to appear in vCenter, right? And the script takes care of that also. It can parse the data stores, and it can import the VMs. It can also map port groups, and when the VM comes up and says, hey, you know, did you copy it or did you move it? The script will answer the VM as I moved it, okay? So basically, if you are familiar with VMware SRM and how it functions, the script kind of, you know, has similar functionality to VMware SRM, except on a more basic level, okay? So obviously, if you have VMware SRM, you can use it, but if you don't, then you use something like this script, okay? Once the VMs are in vCenter, at that point, the script powers the VMs on, and then uses the add HV desktop commandlet to add machines to the proper pool in the DR site Horizon infrastructure, okay? And then once the machines are all added, I use the set HV machine commandlet to assign the users to specific machines, okay? And remember, you know, that information you have is from 1 day ago, from that other script that generated that CSV mapping. And when you use a set HV machine commandlet, you know, you want to make sure that you be very careful with syntax. Like I said, these commandlets have been written by VMware and the community, and there's a lot of bugs, you know, and sometimes it doesn't account for error correction. So it just, you know, if you do the syntax wrong, it'll just error out, and you wouldn't know what's happening, right? So you make sure, pay attention to syntax, right? Do it exactly the way that it's written. The two scripts I will publish. I haven't done that yet, but I will publish these scripts on my blog, cloud-zebra.com, over this weekend. So if you go there, there'll be information. There'll be the presentation, this presentation that you see, and the scripts. Okay. So finally, we talked about you know, at least 3 different designs for Horizon. But of course, there's lots of other components in Horizon. So how do you protect them? Okay. Well, you need to worry about user data. You need to worry about the user profiles in application settings and applications. Okay. So for all of these designs, right? But especially important for non-persistent designs, right? So for non-persistent, remember, let's talk about user data. User data for non-persistent has to live outside the desktop, because for non-persistent, as the desktop is logged off, it is destroyed, right? So user data has to live outside. So what you want to have is you want to have distributed file shares that are replicated between 2 sites, and they should be replicated using a distributed replication technology like, you know, Microsoft DFS or EMC's Isilon, right? Can you have a file server that is not, you know, always replicated, always in sync, but, you know, replicated using something like SRM, right, in a standby fashion? Can you have that? Yes, you can have that, but if you have that, then it's going to take some time for you to recover that on the DR site, right? You're going to need to bring the file server up, make sure it's okay, and then you know, make sure that your user data is pointing properly to the proper file server, right? So you might need to, you know, change some DNS entries, right? So you're better off using distributed file sharing between the 2 sites, right? You also want to use a folder redirection for desktop, documents folder, you know, as much as possible, okay? So the users don't store anything on their desktops, right? again, if you are doing persistent desktops, full clones, the last design I talked about, users may have data stored on their machines. But that's okay, because with the full clones, you are replicating them the whole thing, and when the desktop will come up, the user will only lose 15 minutes, depending on your RPO of your replication tool, 15 minutes of data. Okay. So for persistent, it's less important to have user data outside, but if you can help it, you still want to do that outside the desktop. Okay, makes things easier. If you are using Dynamic Environment Manager to manage profiles and manage application settings, you want to make sure that the profile data is also on the distributed file share, right, which is available in the secondary site in case of a disaster. You also want to make sure that you install the management console for DEM ahead of time in the DR site, so it's already available, so you don't have to fumble with the management console in case of a disaster, right? So how do you manage applications? Well, again, remember that for non-persistent desktops, you're probably going to have some applications installed inside the image, but you want to have as many as possible outside the image using app volumes. Okay, just because it's more convenient to manage them, and it's a lot more flexible. Okay, for persistent desktops, full clones, you don't necessarily have to have applications outside. They can all be installed inside the image, right? And they will all appear on the other site. So then you don't have to worry about application layering, right? But if you use app volumes for application layering and have your applications outside the image and you dynamically assign them on an as-needed basis, then you want to make sure that you have app volumes manager on each site and you use storage groups to replicate your applications. And for the app volume SQL database, you want to make sure that it's protected using standard SQL technologies like always on, which essentially creates a an active or active standby database between the two sites, right? So when you fail over, your app volumes still sees its database in a disaster site. If you have other application deployment tools in like Microsoft SCCM or something, then you're welcome to just use those, and those usually have their own ways of doing DR, right? Which is they usually have secondary repositories and DR sites that could distribute applications again. So for example, one of my clients has persistent or dedicated link clones. So when they fail over, they will use Microsoft SCCM to redeploy all the applications. Okay, and that could take a while, right? Redeploying all the applications back on the desktops, right? So that's how you approach user data profiles and applications. Here's that picture again that we talked about, right? If you look at the middle section, you can see for the apps, we're talking about app volumes here, and you can see that there's app stacks, and they are being replicated over to a secondary site. Okay, app stack with all your applications, and also your writable volumes is replicated to the secondary site. Okay, and therefore they're going to be available. For the profile, you are replicating user settings for your DEM. You're replicating your home file shares. Okay, and anything that's folder redirected, you're replicating, and that you want to be able to accomplish, like I said, with distributed file sharing if you can help it. Okay, if you don't have enough money, you can just use Microsoft DFS. It's not the greatest, but it's okay. So how do you protect? So we talked about everything else. There's another component in VMware called Workspace ONE Access, the former VMware Identity Manager. And that is a kind of a unified portal and a single sign-on tool that can be a front end for your Horizon 7 infrastructure. Not everybody has this particular piece, but if you have it, the way to protect it is you want to create a 3-node cluster per site, okay? You want to use a load balancer in front of it so that the load balancer distributes the connections to one of the cluster nodes in the DMZ. And then your connector appliances are going to be on the internal network, okay? And they're going to communicate with the access appliances in the DMZ, right? That's if you have a single site for high availability. You want to have that. For multi-site, you need to make sure that you have, for the SQL database, again, you have something like always on to have active standby database in primary and secondary sites. You want to create a passive cluster in the DR site. And you're going to have to do some manual steps for recovery and for preparation, like editing runtime config. The older way was that if you don't have VMware Site Recovery Manager, then you built a passive cluster. When you need to fail over, you make sure your database is okay in the DR site. You manually bring up the passive cluster in the DR site, and if you don't have global load balancers, you make sure that you give your users the new URL to access. Okay, that's how they would access the Workspace ONE Access. If you have VMware Site Recovery Manager, you don't have to build a passive cluster. Okay, you can have Site Recovery Manager protect your production cluster and fail it over in case of a problem. Okay, that is supported now. It used to be not supported, but now it is supported. And when you fail it over, at that point, you need to make sure your database is there too. If you're failing it over using SRM, you need to make sure it's there. And you're going to need to make sure that your settings are correct. And that's probably going to take you anywhere between 1 to 4 hours to massage, right? And that's what your RTO is going to be. Okay. RPO again is going to depend on your replication tool, all right, of choice. Here's the picture of what I just described, right? We have a global load this picture uses a global load balancer, right? So if you have a global load balancer, you're not going to need to have 2 names for your 2 different sites, but you're going to have only 1 name, right? And the load balancer will automatically, depending on which site is present, distribute the load to one or the other, or if site 1 dies, it will go to site 2. And you can see here, right after the load balancer, there's the Workspace ONE Access nodes in the cluster, in the DMZ, in each site, okay? And then there's the connectors internally, and the SQL database is protected user SQL always on, so it's distributed between the 2 sites. All right. So again, this picture is the old way, the kind of a standby way of protecting Workspace ONE. This is not the VMware Site Recovery Manager picture. Okay, but Site Recovery Manager can be now used. And finally, we have some general high availability tips that I see, particularly now, during coronavirus. You want to make sure that your infrastructure is, nice and stable, and you allow your users to connect from home. You want to try to use load balancers if you can help it. If you don't want to buy the more expensive ones like F5 or NetScalers, you can buy something like Kemp. Okay, which are cheaper. However, more advanced load balancers can do more advanced things, like, for example, in a cloud pod configuration. Remember how I said, cloud pod, you connect to cloud pod, and it's going to know based on Active Directory where your user resides, but it's not going to know anything where necessarily your user is coming from. Okay, an advanced load balancer can say, oh, you know what, my user is coming from this particular source VLAN A, and that is in site A, and therefore I'm going to route this user to site A. And that way, if the user is routed to the correct site, CloudPod does not have to route the user, and therefore, you're not using your data center interconnect as much, okay? Because the load balancer accomplishes the initial placement versus the CloudPod. So advanced load balancers can do that, right? You want to try using the connection server non-tunneling mode without the blast and PCRIP checkboxes checked, right? You don't want to check them if you can help it. What does that do? Well, what that does is that the connection server sets up the connection to the virtual desktop, and then the actual data, keyboard, video, mouse, starts going around the connection server. So the connection server is no longer involved in the actual data flow, right? It only monitors the connection. Okay, and how is that better for reliability? Well, if something were to happen to your connection server, it doesn't matter because your connection stays up. Okay, if your users are internal, the connection is between the Horizon client on your some sort of a hardware PC or a thin client and the virtual desktop directly, right? Bypassing the connection server, right? And so, if one user has a problem, so it's only affecting that one user, all the other users are still connected, right? If the connection is external, the external connections still go through the UAG or security server, and then go to the desktop. So, the connection server is not passing the connection, but your UAG or security server is passing the connection. So, externally, if the UAG goes down, then the connection will go down, right? But at least the connection server is not in the path, right? If there are going to be situations where your security team says, you know what, I don't want to allow the whole VLAN of desktops to be available, and configured on the firewall, right? So from all the Horizon clients hardware devices to all the virtual desktops, if you have what I said here, number 2, if you don't do tunneling, then on your firewall you have to make sure you allow your VLAN with your Horizon clients access to the VLAN with the virtual desktops, right? And it has to be fully open, right? Sometimes the security team says, I don't want to do the whole subnet, forget it, right? And so in that case, you're forced to use tunneling mode. In that case, the security team can only allow that one IP of that one connection server because all connections go through that, okay? Also, if you have a problem where you want to use HTML access, but when HTML access is being used, it at some point in the connection, it goes to an IP address. And at that point, in the browser, it can display to you that there's no certificate for that desktop, right? If you don't have connection server tunneling, right, that may be a problem for you, right? If that's a problem for you, then use the tunneling mode, okay? Remember, if you use the tunneling mode, connection server supports up to 2,000 connections, so it's a lot of connections, and you can have up to 6 and 1 passive servers in your one block of Horizon infrastructure, right? So connection servers can support a lot of connections, so it's not a problem to pass connections through them, right? But again, if they die, all those connections are dropped, okay? Finally, the blast protocol Blast protocol uses port 443 and 8443. Those seem to, pass easier through firewalls, easier to configure. Lately I've been noticing it's just every time you configure Blast and PCRIP, Blast seems to work right away, and PCRIP needs a lot of massaging to do, right? I know VMware prefers Blast, but I still use PCRIP in certain situations. For example, Blast performance I find with high latency, if your users are over in India and you are in the United States, and you have high latency, if you have GPUs, NVIDIA GPUs backing your desktops, then Blast works great with high latency. But if you don't have GPUs, and a lot of people don't, then I find PCRIP works better. Again, this is just anecdotal evidence on my part, but that's what I find, right? But then again, Blast seems to pass easier through firewall, so that's its advantage. Okay. And that's it. Yeah, you're welcome to contact me on LinkedIn or by email. I'm going to publish this presentation and the scripts on cloud-zebra.com. If there are any questions, let me get out and check to see the questions.
I didn't see anything come up in the chat.
No.
Does anyone want to unmute themselves and ask a question? Bueller? No one?
Well, I see one comment from Sean Bolden about comprehensive content. Thank you for that. But I don't see anything else. At this point,
good stuff, Yury. Thank you.
We're good.
Hey, one question here. This is Andre Bellotti. Hey, Yury, how are you? I came very late. I got stuck to another. So is this your session being recorded, and can we, access it later?
It is being recorded. Yes, I'll post it online and share it when the event's over.
Excellent. Thank you.
Of course.
Yes, and there was another question came in from James Tamayo. Same thing. Will you be providing slides recording? Yeah, I'll provide slides and the scripts on my cloud-zebra.com, and then Ben, if you give me access to the video, I'll provide the video also on like YouTube or something.
Okay, awesome. All right, let's take another 10-minute break, and then we'll finish up with Frank and Chris talking about what's new in NSX. There were a few people that came in late. If you can please complete the Google form, the link that I posted in the chat, so I can keep track of who attended today and who didn't. That would be very helpful. And that's it. We'll come back in about 10 minutes or so. All right, guys. Let's say 12:45. 12 minutes. Thanks, guys.
Sounds good.
While people take a break, if anyone has anything they want to talk about, if anyone has anything they think they might want to present at a future event, either online or next year in person, whenever we can, whenever this quarantine ends, if it ever does. Feel free to unmute yourself and we can have a discussion as well. Chris, it looks like you and I are the last ones sharing video, and that's it. Everyone else either gave up or left.
Oh, Yury.
Oh, there you go. Yury's back.
I'll share. I have to compensate for my video not working earlier.
That's funny. I think everybody's nervous because of the things that you see on the internet or on like some of these newscasters that stand up and they don't have pants on or shorts or whatever. And I think everybody, if you're going to get away from your desk, you do shut it off.
Yeah. I think, there's a number of people that just roll out of bed and sit in a chair and start working and don't bother getting dressed or anything. And listen, I get it, but I started working from home, being a remote employee last year, and it works a lot better like mentally to actually get up, shower, get dressed, sit at a desk like you're going to work, versus just rolling out of bed or even staying in bed and just reaching over, grabbing the laptop, putting it on your lap and starting to work. Like just mentally, it's better to try to separate the two.
That's true. I do this. I do the same thing. I have to get up. I have to get dressed, do your hair. The only thing I don't do that I wish I did is I haven't been putting my watch on, and I'm a little lost without it. But yeah, exactly. So, but yeah, I have to do it, and really, you save the commute time, right? You save a lot of little things. So if you take that time back and get up the same time you normally would and enjoy that, it's cool. Otherwise, somebody else on this call, we were talking about the ability to get out of bed sometimes. Because if you don't push yourself, you'll end up 11 o'clock, 11:30, you're still in your pajamas sitting with bedhead.
Yep.
Hey, Chris, is this your home office?
I wish.
Oh my God, I'm jealous. This is gorgeous. I know it's the Zoom background. I know.
So, Chris, show him your garage, though. That's pretty impressive.
Oh my God. It's just stacked with stuff. I'll show you.
Nice.
A little different. It's a little different of a scale, right?
There you go.
Yeah,
hey Ben, was there a problem in initially starting the event, or you started right on time?
No, we started on time.
I had problems at early in the morning because I got in, it put me back into the registration mode, and it was like an infinite loop. I don't know why.
Really, that's strange. I'll definitely post the recording once the event's over. So you got it.
And Ben, we're gonna we'll share our slide with the audience.
Awesome. Yeah, if you send that to me, I can post it in the NJVMUG workspace so that other people can see it. That would be great.
Is anyone talking, or am I the only one not hearing anything?
Nobody's talking.
Ah, okay.
No, I was starting in a quarter of a few more minutes.
Okay, cool.
Niran, I wanna set up my a face like that for mine. I want to borrow yours.
Yeah, I like that.
That's really cool.
Did someone draw that for you, Niran, or how did you make that?
Yeah, it's called Fiverr. I just, paid someone $5. Yeah, well, actually, I paid twice because, you tip them. So if you give a good tip, for us, it's not a big deal. But these guys, $10.
Yeah.
Huh. That's really cool.
Where did you have it done?
No, you go to Fiverr and you can look, for example, you'd say, I want to have an avatar. And there's a lot of different styles that people do. Obviously, most of them copy each other, but found a nice one.
Nice.
So that's yeah, they did that. It's pretty cool. Great session, Yury.
Awesome.
Thank you, Andre.
I'm ready if you are, Ben.
Go for it.
Cool. All right. Welcome, everyone. I really appreciate staying on a Friday afternoon. Today, we're going to be covering some of the highlights of NSX 3.0. There's a lot to it. So Ben gave me an idea. So if you want to follow up specifically any of the new features with NSX, or if you're not familiar with NSX at all, Chris, Jason, or myself can definitely meet with you individually, or if there's consensus and we want to dig deeper in a certain features with an NSX or do some whiteboarding, we're definitely willing to do that. So we could talk about that later, Ben. That works. So a little background on, Chris, Jason, and myself. We're network and security TAMs. We came out of the TAM organization. This group was developed as NSX really started to take some, really started exploding with our customers, and then you needed people to really help from the professional service organization to really help them deploy NSX and identify use cases and things like that. So we're part of if you're not familiar with the VMware TAM organization, and we're part of professional services. Just a bit of a plug, I won't go over, but this is kind of a highlight of the services that we offer. So today we're going to be focusing on some of the new capabilities of NSX T3.0. If just a little background, so NSX V was predominantly the solution for customers, and it focused on VM workloads. But as native apps started coming to the market, it really wasn't the right fit for those particular workloads. So we developed NSX-T, and really we're going to be eventually bringing over NSX-V into T. So we're going to be sunsetting that product, and it will be just we'll end up dropping the T, so it'll be NSX. So NSX T3.0, which we're going to be talking about today, is huge enhancements. And again, there's a lot to cover in an hour, but we'll do the best we can, and we could dig in deeper. I didn't want to get too much in the weed in case some folks weren't really familiar with NSX. So I just want to talk some of the high points and how NSX might help them in some particular use cases. So right now, as you know, we're all living it. The pace of change in IT has been incredibly challenged. The complexity is a huge challenge. Hardware-based architecture is inflexible and expensive. And really, like I mentioned, as the cloud-native apps become prevalent out there in the cloud, it's just not really the right solution. So like Niran mentioned earlier, as you know, VMware is known for abstraction, first abstracting compute, then storage, and now the network, as well as security. So, it really really made sense for us to, focus on network and security. So really, with NSX 3.0, we have the full stack L2, layer 2 through layer 7, that's in pure software. As well, because it is software-based, it can run anywhere, meaning on-prem, in the cloud, at the edge. So again, abstracting from the hardware constraints. And automation. So not only do we offer software-defined from layer 2 to layer 7, we can also automate at every level of stack. So right now, NSX can run on VMs, containers, and bare metal, again, both on-prem and in the cloud, from switching all the way up to analytics. Now, if you weren't running NSX and you wanted that same functionality and feature that NSX 3.0 gives you, you would have to get a combination of solutions, both hardware and software. And here's some examples of what you would need to be able to do to accomplish what NSX can do in one solution. So here's our whole security portfolio. There's a lot to it, and today we're just going to focus on what NSX brings you, specifically with NSX 3. So obviously, traditionally with NSX, the data center is the meat and potatoes of NSX. NSX Cloud, some of the enhancements that we already did offer NSX Cloud, both in Azure, AWS natively, obviously VMC and AWS, as well as Google now. But we also with 3.0 now have NSX supported within GovCloud, and that's a huge enhancement for me personally. State of New York is my customer, and they've been waiting for that. So they're migrating a lot of workloads into Azure. So for NSX to be able to run in GovCloud really opens up a lot of opportunities for them. And then as I keep telling Niran, my favorite feature is distributed IDS IDP. Right now, we're just offering IDS. IDP will come down a little further down, but I'll get into the advantages of that in the architecture. Is that a question? Oh, it's Niran. Oh, by the way, if you have any questions, we have Jason because Chris and I are going to be bouncing back and forth, and we didn't want to hold anyone up. But if you have any questions, Jason's available. Jason's a rock star, so he can answer anything that we're talking about or even beyond this topic within NSX. So he's standing by.
Yeah.
So this afternoon, I'm going to really dig into the capabilities with NSX3. The first set of enhancements, the first one being federation. And what federation is going to be able to do is let you manage a multi-site hybrid cloud NSX environment. And like I mentioned already, we've added GovCloud. Chris is going to get a little bit into some other enhancements around VRF routing and dynamic service chaining. Like I mentioned, I'm going to be talking about IDS and how that works and how it's architected. NSX intelligence, very important as part of our whole security solution. It's a lot of analytics built in that, some ML to do some proactive management with security. And then we also can offer distributed firewalling for Windows 2016, which is new with 3.0. And another huge enhancement, like I mentioned, NSXT was really developed as we moved toward cloud native apps. So as we launched vSphere 7 with Kubernetes, which was previously known as Project Specific, we now have NSXT being the actual networking solution for that, and we'll get into that deeper. And then the other thing Chris will be covering as well, talk about converged VDS. Caveat on that, and Chris will get into that as well, is that if you don't know the switching architecture right now, NSXT, there's a separate distributed switch called NVDS, and then you have traditional VDS. And the reason we did that is because we decoupled NSXT from vCenter, but since 3.0, we changed that model. So we've actually, if you're running vSphere 7, you can actually come down to a converged VDS, which makes management much easier, especially in a larger deployment. So let's start off with NSX Federation. So really, what NSX Federation does, first of all, if you're familiar with NSX, you're familiar with the NSX Manager. What we've done is we've added the Global Manager, and this opens up the opportunity for many more use cases. And the Global Manager really allows you to manage a multi-site NSX environment. And this can be a combination of on-prem or in the cloud. Right now, we do not support VMC on AWS for Federation, but it will be coming soon. So, this is some of the use cases, DR, and hang on. So really, let me open this up for you. So what happens is traditionally the administrator would they would log directly into their local manager. And each one of these locations would be a different NSX environment. So what we did, we pulled in the global manager. So now the users come in and they configure their policies within the global managers, and then they're fed down to the local managers. Then we have we offer a standby global manager for redundancy in DR situations. Again, one caveat around this is that you can still with 3.0, you can still log into the local managers and do some configuration. However, those configs do not go up to the global manager, so they'll be unique to that site. So again, if you're going to deploy Federation in this kind of architecture, you want to do all your configuration at the global manager. So here's some of the use cases currently, and I'm sure they'll grow. Right now, having consistency, like I mentioned, having consistent security across all your locations on-prem and the cloud. Simplified disaster recovery. We had a disaster recovery solution previously in NSXT, but it didn't scale as well, and it was a little more complicated to configure. Right now, with having federation and adding the global manager, it makes it much easier. It's literally got one click cut over to your DR situation. And then, efficiently managing a metro DC resources. They have, resources spread over in multiple locations. So here's an example of managing the policies across data centers. So for example, if you had, your test environment in location 1, now with the global manager, if you wanted, your test VMs not to communicate with your dev or prod, and you configure it the global manager, wherever that security group is that you built, regardless if it's on-prem, in the cloud, that will always be protected from whatever. However you configure those policies will follow that VM in whatever location you're at. Now, disaster recovery, again, we had it in NSXT, but it wasn't quite as, it was very complicated to configure and administer. And actually, when you went to a DR scenario, there was a lot that had to be done. So again, having the global manager and having an active global manager cluster and a standby cluster. If you go over into a DR scenario, you can one-click switch over to your standby location. And using SRM, I don't know if Zerto's supported yet, but I know SRM is. So you use SRM to spin up all your VMs in the DR location. And then the third one is the Metro DC pooling. So in effect, you're using data centers that are pooled as a set of resources. If there's a failure in one of the data centers, the customer can simply move the workloads to a different data center, since all the DCs are considered as one single pool. The requirement for this is you would need to stretch layer 2 among these locations. These locations, by the way, I have one customer that actually is going to be deploying Federation. They're a service provider, and they're actually treating each rack, because they're a different tenant, as a location. So you could even go down to the rack as far as when I say location. So again, just to reiterate, just the benefits of having, NSX Federation, a consistent policy across all locations, single pane of glass, which that's huge when you grow into a large environment, and obviously make operations much more simpler. So now I'm going to hand it over to Chris, who will be digging into VRF, service chaining, and some of the enhancements with the converged VDS. All yours, Chris.
Thanks, Frank. So yeah, like Frank said, tons of new features. It actually, the more we go through them, the more I start to realize that there's more and more little features that we didn't even get to, right? So the feature to talk about now, the next one, is the virtual routing and forwarding, right? VRF Lite. So the way we're using VRF Lite today is we have a single tier 0 gateway for every single tenant in the network, right? And that's represented in the picture. Go back one, Frank.
Sorry.
Okay. So this means when you want to introduce a common services into your network, you have to deploy it on a per tenant gateway configuration, right? Otherwise, obviously, your tenants won't be able to reach the outside. So basically, any tenant-specific configuration that you want to build, it needs to happen from a distributed fashion on every single tier 0. And it also leads to a lot of edge nodes being deployed into your network, and it's just not very resource efficient. right? So let's go to the next slide. Now in NSXT, what does it really do for us, right? So we're basically now consolidating all the T0s into something called what we're calling a VRF, right? In a single T0 gateway. Next slide, Frank. Sorry, next, yeah. So you deploy a VRF for each tenant respectively within a T0 gateway. You have a tenant A for A, you have a tenant B for B. And then you'll see, as on the picture, the VRF A and B are represented within the T0. So you go and you connect your respective networks into those VRFs on that single T0 gateway. And so this basically provides the tenant the isolation within a single T0 gateway. And this means you could deploy a lot less T0 gateways in the network, and basically introducing a separate routing table for each VRF, right? So security-based simplification, at the same time scalability, and we're actually going to be able to take that all the way up to, I believe, 100 VRFs per T0 gateway. So the next feature, networking type feature, is it's tied to VRF Lite. You'll see it's similar even the designing and the architecture, is L3 EVPN. So with this feature, we're delivering it mostly for telco NFV customers, and a specific use case that it was developed for is to support APN isolation or corporate APN across a telco network. So if you look at the diagram, you have two customers using two different APNs, and the goal is to maintain that isolation all the way through to the core. Right. So the way to achieve that is very similar to what we did with consolidating the T0, right? So we run EBGP from the customer environment up to or through the T0, and then we run MP-BGP or multi-protocol BGP on a per VRF basis, right? From the T0 into the telco core. So an important thing to note, when they created this, this is not an enterprise use case, right? So we developed this specifically for the telco audience. So it's important to note when you start going through certain use cases and just where they're designed for and what they're designed to fit, right? Most enterprise use cases within that we deal with typically are looking for L2 EVPN, and that's actually a roadmap for us. So more to come on that. All right, so yet another feature is dynamic service chaining. So we support it across the on-prem data center, NFV, and NSX cloud. This operates very similar to north-south service insertion feature, that we have today. But instead of directing traffic to a single service in the network, we define a chain of services to be used for a particular flow of traffic. So when you look at traffic coming in from the uplink into the network, it goes through a classifier which identifies the specific chain of services that needs to be applied to a piece of that traffic. So this chain is defined is defined in the management. This chain is defined within the VMware management, which is the NSX manager, and the partner management systems. So once you define the chain, the traffic gets forwarded to those specific services in the network. Sorry, that was a little bit of a tongue twister for me. So in this scenario, the traffic coming from the uplink gets classified and then gets forwarded to the next generation firewall IPS and network monitoring services that you have defined in the chain, right? So that's what brings it all together. So this really allows customers the flexibility to take the software-defined set of services and to apply them to the traffic coming into the data center. So distributed switching. I want to spend a little bit of time on this. So converged VDS. So this is a networking feature that many customers that came into NSXT in the beginning and then had to switch over when we got to 2.4 were probably wondering, hey, when is VDS going to come back? So what we did was we ended up adopting when we, trying to figure out how I want to say this. So when we created NSXT, we wanted to separate from the vCenter and separate the vCenter in a way that we could use it for other things, right? We wanted to use NSX in a way that can be used with KVM and other things like that, right? And in order to do that, we decoupled from the vCenter. We ended up losing a lot of the functionality from it, or a lot of the inherent sharing, you know, even of inventory right off the bat. So when you lose that, they needed a way to reintegrate things. So they created the NVDS, and the NVDS was what we were, it was basically the same VDS, same functionality, but it was basically created, owned, and managed from the NSXT side. And when they created that, they were able to share it back to vCenter. You were able to see it, look at it, but you couldn't manipulate it. So a lot of users that were adopting to the 2.4 weren't necessarily used to that functionality. But from VMware perspective, we wanted to be more agnostic, right? We didn't want to be just tied to us because of the way things were going. So with that in mind, there was a lot of confusion, but some adoption challenges, right? Where we had to learn another way to connect back, but that was the way to enhance things as well. So backed by popular demand now, we were able to bring VDS back in. But to Frank's point before, VDS is only brought back in vSphere 7. So the integration needs to be vSphere 7.0, VDS 7, and NSXT 3.0. So, but it does, what we get out of it is it does simplify the operational properties of the environment, right? So it's basically, it simplifies the NSX deployments on vSphere. You know, we don't have to make changes to the existing VDS environment anymore, or not as much, right? So what does it really mean for customers? You know, they really don't need to upgrade their vSwitches to an NSXT and VDS. You could just plumb it over right into the ability to run NSX. And then they could also now go back and start using their distributed port groups on the VDS from the vCenter, and simply just simply just use existing ports within the NSX internally. So I just covered a lot of it on the other slide, but I did want to use this slide to give a lot of background on the differences of where we came from, right? Which I did, right? The differences of NVDS, but also what VMware was doing at the time, the importance of bringing VDS back and the simplification of it. And with simplification brings strength, and that's what this slide's all about, right? It's less disruptive now. We have, it's simpler to implement microsegmentation use cases because we're tied back towards something that's already being presented from the vCenter. So another thing is, it makes it a lot less effort when it comes to time frame on deploying new environments, like even doing a brownfield deployment, or for even a greenfield for that matter. They're just a lot simpler going forward. So I'm really excited about that feature, and there's a lot of buzz about it. Next slide. Most people know by now that we reintroduced, or that we started being able to deploy on bare metal. But when we're basically increasing our bare metal support. So all of our messaging is ubiquitous policy administration for any workload, any application, any endpoint, and of course any cloud, right? Just like Frank had touched upon for the other pieces before. But we were sometimes limited when it came to bare metal. So we're going to further that capability by introducing support now within 3.0 for vSphere bare metal of servers of Windows Server 2016. And then as far as messaging and future messaging, we're going to enhance it further with updates to NSXT for Windows Server 2019 in future releases. So we're making the moves towards keeping up with the times in that way when it comes to bare metal, where we may have been limited in the past. And that's it for my features for right now. So back to Frank.
Cool, thanks, Chris. So now I'm gonna, like I mentioned before, other than security, you know, giving support for modern apps has also been a huge initiative for VMware. I'm sure you're aware, you know, we acquired a company called Heptio. The founders of Heptio work for Google, and they actually are the two who actually developed Kubernetes when they were working at Google. So we're, you know, obviously making the right investments to make sure we're tightly integrated with Kubernetes. You know, we definitely see the world going that route. So, you know, with project specific, now we know as vSphere 7, integrated Kubernetes is the way we're going to be moving. The NSX container plugin has been quite extensible in the past. We already had adapters for such things as Cloud Foundry, Kubernetes, and OpenShift. Now we're adding even more. We've designed this NCP for scale, which is huge. We can handle up to 50,000 pods now in NSX 3.0. We added the distributed load balancing to allow pod-to-pod communication within namespaces. And now we're truly provide level 2 to level 7 networking, not only for VMs, but also for containers and bare metals for one platform. So let's give a quick overview of you know, vSphere 7 and Kubernetes. We have native Kubernetes integrated directly with vSphere now. Now ESX can be turned into a supervisor cluster as we build the Kubernetes cluster into the ESXi hypervisor. We also built something called a Spherelet. This is a custom kubelet that is the agent that watches the actual state and compares it to the desired state for the pod specs that is defined by the operator. In addition to the Spherelet, we also built something called the CRX, and the CRX is a container runtime based on Linux kernels, because you need a Linux kernels to run containers. So we built this into ESX, and now we can run containers natively. So let's look at what I'm going to build out to a supervisor. So this is basically, using, because Kubernetes is built in with ESX, we can now build a supervisor cluster in an ESX. So let's look at how we how this gets built out. This can all be managed in vCenter. So one of the concerns I know with some traditional virtual admin is, they have to retool their skills. I mean, eventually you do want to definitely understand Kubernetes and be able to manage a Kubernetes environment, but out of the gate, you don't have to. The first thing we need to do is, as you would normally, configure the host with NSX, ESX, and storage. And then you add the supervisor cluster on top of ESX. The VI admin needs to add the namespaces. And if you're not familiar with Kubernetes, and I think Niran went over this, the namespaces are resource isolation within Linux. Just build this out. So for example, the VI admin can create namespaces for things such as your dev, test, and prod. They also create namespaces based on lines of business, and also some will maybe creating namespaces based on, databases or front end of the application. On top of this, the VN admin can then add native pods and VMs in the same environment and expose them to developers. All this can be done within and managed within vCenter. A lot of clicks there. So let's look at the plumbing provided by NSX. Like I said, NSX is designed into vSphere 7 Kubernetes. NSX is now the default networking solution for containers. So what you're seeing here is T1 and the supervisor are connected to the physical network. And the guest clusters where the DevOps folks can consume is also being plumbed with NSX with the T1 routers. The sparelets that I mentioned earlier is the interface that with interfaces with the containers and provides the networking resources. NSX 3.0 now gives the benefits of NSX traditionally that we develop for VMs and makes them available for a container and Kubernetes environment. So on the supervisor cluster, we'll focus on the supervisor here. For east-west traffic, is provided by routing, NSX routing and switching. And connectivity within the namespaces, for example, so within this name, for example, within marketing. For these two pods to communicate, we're using distributed load balancing. And for north-south communication, the NSX will offer NAT, firewalling, and load balancing as well. This all could be controlled by native Kubernetes networking policies. So you can use your native Kubernetes commands to manage your network as well. So as we dig down into the guest cluster, we offer similar features to yourself. Also, anyone on the team that needs consume anything in the guest cluster. For example, a developer doesn't have to ask anymore. They just say, I need a Kubernetes cluster. I want to mention that DevOps is not restricted to use the NSXT and CP. They also can use their choice of third-party CNIs. So now, I did go through that pretty quickly. We can spend, as Niran can attest, we can spend, hours just focusing on this aspect and the enhancements within, NSX with Kubernetes and containers. It's a huge advancement and gives us huge opportunity in the market. But again, like I told Ben, if there's things that we want to drill into, there's different use cases, technology or aspect, we can do that for the group as well. So really what I was most excited about, because I've managed environments, I've managed IDSs, and it's quite a bear. And I find so many times that your traditional IDS has become a pile of iron in the corner, and really no one's paying attention to them because you're just flooded with alerts and you just can't keep up with it. So what we did, which I thought was pretty ingenious, is we took the distributed firewalling architecture that we already had with NSX for quite a while now, and we used that architecture and introduced IDS into that. Like I said earlier, we'll be adding IDP to that as well, but right now we'll focus on IDS. Now the IDS is going to bring in advanced threat detection capabilities that your traditional IDS would be, but we're distributing it, and I'll show you some of why this is going to be an advantage. Your traditional IDS can create thousands of alerts, and companies don't really pay attention to those alerts. Also, traditional IDS is, as I know, become administratively intense because constantly tuning them and keeping up with signatures. With NSX IDS, we're able to push the signatures that are relevant for only the workloads running on the particular instances. So that for one, the false positives are going to be dramatically reduced. You're not going to have any blind spots because your IDS is sitting right next to your workloads. Just like, again, distributed firewalling, we're basically distributing. You're not like with a traditional firewall, you have hundreds of, could be thousands of ACLs. But with distributed firewalling, you could be really granular and just block what needs to be blocked based on the workload. Same thing with IDS. Now you could be very granular with your signatures. For example, if you had a cluster that was running MySQL, then you just would have signatures loaded that are relevant to MySQL, and same thing with Oracle. Now some of the use cases is pretty self-explanatory. The number one use case, obviously, and why everyone has IDS is really a checkbox for HIPAA, PCI regulations, but is it really being used efficiently? Creating security zones, that's another, you can't do that within a physical device because, it would be cost prohibitive. And another use case of NSX's IDS solution is, it's purely software. There's no hardware involved. So again, just to keep reiterating, three things that differentiate our IDS solution. First, it's built in across the entire fabric, similar to the way distributed firewalling is. It's not a bump in the wire. What I mean is, it's sitting out with every application and protecting every application. And finally, it brings simplicity for developing and managing the IDS, which has traditionally been a huge challenge. So again, I just want to include this slide. This is a very simple diagram of what your traditional IDS is. It usually we set out the edge in or centralized as a cluster. Huge amount of compute power needed, storage as well. And many vendors, IDS, from what I remember, would charge by the throughput, which would be cost prohibitive. So you'd have to be very judicious as far as what workloads you'd be you would protect IDS, and usually we just would focus on anything that had PCI workloads or HIPAA, things like that. Again, the problem there is that you start creating, blind spots with your environment. You can be moving workloads and you're not making adjustments to the IDS. And that brings up another point is that, when you're vMotioning workloads from one location to the other, IDS is not aware of that. In a traditional IDS system, you have to, manually make changes to that to follow that workload. Again, because our solution is distributed and it follows that workload wherever it is. If it moves up to the cloud, then IDS will follow it. And here's an illustration. Oops. So here's an illustration of what our VMware's IDS solution will give you. Went too far. Again, you can see it's quite small, but again, it's just showing you that it doesn't matter, where the workloads are, they'll always be protected, and have threat protection available. And this is a good diagram that kind of illustrates what I mentioned before. As you have different workloads and different applications, you're no longer managing them centrally. Traditionally, you're not able to break them down by application if you're essentially doing IDS. Because we are distributed, again, if you had to have signatures just for your MySQL, then you just load the MySQL ones for that particular cluster, and so on. Tomcat, Apache, and Oracle and such. So the strategic benefits, elastic throughput, simplified architecture, operational simplicity, definitely. And by the way, this is all managed. I should have mentioned this earlier. This is all managed within the NSX manager. So there's no, you do not have to get additional appliances to manage the IDS. It's pretty much managed very similar to the way you would manage your distributed firewall. and policies. So anyway, that's all I have on that. Again, I wish I could go a lot deeper into that. We can do a demo. We have labs set up, building hands-on lab for IDS, but I think it's going to be really important as people look at IDS. So with that, Chris, I'll give it back to you to cover NSX intelligence.
Sounds good. Thanks, Frank. So yes, NSX intelligence, another really, really cool embedded feature. So with the NSX intelligence comes an inherent observability that we've never had in the UI before, right? So let's go to the next slide, Frank. So while other solutions really rely on an extensive set of complex operations involving inefficient traffic management techniques, and really they redirect the traffic to expensive appliances and to achieve anything that's even close to NSX or NSX intelligence is able to do right within the UI. And there's actually, I don't want to forget, there's actually a couple more I even want to talk about at the end of this. Within just the UI is just amazing right now what they throw in it. So we can, with NSX intelligence, we can provide operational simplicity, right? Where essentially just a few clicks, you can view and drill down into all the detail and understanding of your firewall needs. So you're able to take a quick look at what's going on within the environment in a visual representation and be able to start evaluating how you want to do your policy. So the distributed nature of NSX and NSX intelligence operates, it reduces the load on the network, right? And the use of additional appliances of any kind. So you're not, like I just said, you're not sending traffic somewhere else to have it analyzed, to have it come back and make your interpretation of how you want to block it. Our unique placement of NSX is still being able to implement within kernel, right? Or at the VNIC, right? All of our unique pieces are on this internal under the hood piece of the platform, and just having to push out it has a lot of overhead, and it is expensive. So as an integrated platform, we have a unique perspective from the operation of workloads and the alignment of workloads within the virtualization network, and it's, like I said, administrated natively right by NSX. So basically, NSX intelligence is just getting started, right? It really it already achieves a simplification of operations in visibility for microsegmentation, simplifications of compliance analysis, and basically just streamlining security operations in general. Further enhancements are going to stretch the same inherent ability to the cloud-based workloads and microservice architecture that we're implementing by nothing more than NSX software. Within the NSX intelligence, it delves deep into your L7, your layer 7, initially and ongoing. So when you're using it for your discovery work, obviously that's initially, and then ongoing, meaning as you're creating your policy and you're going back and looking how it's affecting your environment, you can keep going back to those visual aspects and see what you're blocking, what you should be blocking, and maybe what's not, and maybe some things need to be fixed. It gives you that honed down approach from a visual connect the dots kind of perspective. So further, while we have our own L37 enforcement within NSX intelligence, it basically allows you to implement security within just a few clicks, right? Because you can implement right out of the UI. Next slide. Okay, well, what about Verni? So there's a lot of confusion around these two. They are at times visually similar. So I brought Verni in to kind of just talk about it from the relationship to network intelligence. So Verni is a complete solution for a network monitoring with support of physical, logical, virtual, and cloud network solutions, right? So with its ability to span physical, virtual, SD-WAN, and public cloud environments, Verni brings a real end-to-end network visibility that we don't always get. And it's tied back to vCenter, and it has ties back to these other components, but still very close to the VMware source. So you can basically say that it focuses more on operations and troubleshooting. And that's probably in the grand scheme of things between the two products where this one would shine over NSX Intelligence, or where it would be maybe better in a way, right? So, and don't forget about the capability to talk to your different teams, right? Being able to talk to your network team and show them what you're looking at, and have them able to log in and see what you're looking at when you bring a problem to them or when you're troubleshooting, right? That was always one of the biggest problems in the past, is not having that one spot to be able to look at and see what's going on outside, right? And that operationally and for troubleshooting, it really does shine, because it's represented in a way that a lot of those teams never had before. So how do Network Insight and Verni work together? So let's go to the next slide. So we're going to together, it still depends on the use case, but I can imagine definitely customers having both, right? For one, NSX Intelligence is an add-on to NSX, while Verni is an independent product. So this means that for NSX environments, NSX Intelligence should be leveraged with respect to microsegmentation and firewall rule planning, right? When you're venturing out to build your, to deploy policy, it's right there in the UI. You have the ability within the product itself to see what's talking and where you want to apply those rules, and to be able to automatically implement them. That's that one-click deploy of rules to the NSX distributed firewall table. NSX Intelligence delves into L7 initially and ongoing. We already said that, and it really, but even with that initially and ongoing capability, it's the ability to automate the rule sets, right, and to keep analyzing them. So together, the solutions can give the customer comprehensive network and security visibility and analytics. As NSX Intelligence matures, the two products are going to integrate deeper and deeper. That's the messaging that's coming from our development or BUs and everybody that's coming together to make these products what we all want. And I think it's really important that they make that happen, because excuse me, the integration between the two, the people who are using it, I think it's important to have different tools that are all part of the same the same overall objective, that is generally the same source or similar sources. It's hard when you go third party, something has to go someplace else and come back and analyze that data, versus being able to all be within the same core of understanding. Just maybe represented or presented a little differently, but the same data. As NSX matures, that will get better. Before I go to Frank for the wrap up, there's other things that we didn't even get to talk about that I probably should have added more slides. But again, you don't think about it until you start trying to remember all the different pieces. So within 3.0, we also have the network topology feature, which is really slick. Again, right in the UI, and you can go in and take a look at what you've already deployed and see your network within the user interface. You click on up top on the policy side of NSXT. You click on you click on networking, and then you go down in and you can see exactly what you have implemented across. I believe it's everything: load balancing, your networking components, and how everything is connected. But in a more like a Visio diagram kind of representation. It's not a Visio diagram, but more like that view. That when you go to the whiteboard to explain to somebody what you just built, it's already there, right? And it's accurate. So that's one piece. There's another one of the traceroute feature, again, right in the UI, where if you're trying to troubleshoot from one place to another and it's local, you can see where things are actually going within a path. That's maybe something that we could talk about on some future VMUGs. Some of those other new features, but just really, really cool. And then there was one last one. Yes, so even within 3.0 and actually the last few NSXT upgrades, just the fact that the API manual is right in the user interface, where you can click up top and go look for what API calls you need to do certain things. I think that level of visibility is really what's making things easier to use, and the reliable source, right? It's already built in. You're not going out all over the place trying to find it. So I think a lot of the new 3.0 features just in general have been pretty groundbreaking as far as cool stuff and what the public seems to want. So that's it for me. I'm going to send it over to Frank for the wrap up.
Good, thanks. As Chris was talking, it made me think of one thing around Federation. Right now, Federation is only supported for Greenfield. So if you have an existing NSXT environment and you'd like to go to Federation, there are plans to have an upgrade path or migration path, but right now it would have to be a Greenfield. So, basically we'd have to build a new NSXT 3.0 environment and swing over the VMs to it. So I just wanted to give that caveat. If you look into, this Federation is something you're interested in. So really, again, like Chris said, just a recap, and we'll be sharing this slide with you. If you look at each one of these pillars, we can spend, a session on all of them. And Chris and I and Jason are more than happy to do that in separate sessions. And if you'd like, one of the things that we can do is maybe do some hands-on lab. Right now, we're in the midst of updating our hands-on lab for NSX 3.0. So we can do an in-person hands-on lab, since we can do all that from home, and we can lead that for you. Just point out a couple important things. Anyone in the federal, state, local that requires your workloads to be on government cloud and you want to run NSX, we now support that. Again, can't say enough about IDS. I know it's only a 1.0 solution, but I've been really digging into it, and some of my customers have, and they're also very impressed with its capability, and definitely on parity with some of the more mature IDS solutions that are already on the market. And having that full integration support for modern apps is absolutely huge. Obviously you heard with the things that Niran's working on, and even some of the things that Chris mentioned, the world going that direction. We definitely need to be close to that, and we're making the right moves to be fully integrated with Kubernetes. So this is just an eye chart that digs deeper into each one of the new capabilities and enhancements in NSX 3.0. And with that, we have a few more, actually we're right on the hour, but if anyone has any questions, we're all here to answer them. So if you want to ask via chat or, unmute yourself. We're here to help you out.
There's a question in the chat about best ways to start evaluating.
Yeah, that's a good point, Sean. And it is a bit overwhelming until you start peeling back the onion. So what we recommend for customers, and that's actually one of the reasons why the NSTM came to fruition, because it is a bit overwhelming. So what we like to do with customers is be very granular on their use cases. Like, let's start with a small use case. And for us, a low-hanging fruit is start with distributed firewalling. Doing macro segmentation. And I say macro segmentation because some people like dive right into doing micro segmentation, at the application layer, and that can get a bit overwhelming. So what we recommend to customers is, do firewalling at the network or cluster level of applications, and then start drilling down from there. Another good use case is VDI. Deploying NSX and VDI is, people think it's, you have to configure so many ACLs because there's so many ports that need to be open. You think to be open to talk to the desktop, but really what it is, it's really 3 ACLs we created. Really, what you basically don't want one desktop talking to the other. It's really where you get yourself in trouble. So that's where NSX is very easy to deploy, and that is full-fledged micro segmentation in that use case. I don't know, Chris or Jason, could you use case low-hanging fruit?
Completely echo. I'll echo that. Definitely start with the use case, but some people don't always have that because they're so overwhelmed. There's not a joke, but there's a term, you have too many options, you don't know where to start, right? So a good way is, if you can't find a use case, then look at the products, look at the capabilities, and see what you would even be able to tackle, or what's in your wheelhouse, right? We have some customers that they're the compute team, but the network team isn't going to sign off on it. So maybe find a use case that doesn't necessarily rely so heavily on that other team that's not so on board right now, right? And then once you find that way to go, you'd be surprised how many of the use cases that were overwhelming kind of go out of the way. Some are just not even relevant to that use case. So the fact that NSXT itself, NSXV even, is just such a beast. You can get through those conversations and the weeds of that. And once you start getting into your specific environment, your specific challenges, is when it all starts to make sense. Then you build the architecture around it of what would I need. And there's help, right? I mean, just even jumping on this kind of a forum, I don't think I've ever met somebody in this industry that hasn't jumped on board to answer a question or explain a use case or build on a use case or just design on a napkin, right? I mean, granted, it'll be a little while before we can actually write on napkins in front of each other, but there's other ways to do that too. So like Frank said, we're part of the NSTAM team, Network and Security TAMs, and we do help customers all the time. So if there's something that's you feel is complex or is a roadblock, just bring it up. Bring one of us in a discussion. Let's see where it goes.
Yeah, and one more thing to add on that is, Chris talked about Fernie, vRealize Insight Manager. Network Insight. That's a great tool. There's a misperception out there that you need NSX to deploy Vernie. That's not true. Really, what we like to do for customers is deploy Vernie, because Vernie can see your east-west traffic, because using NetFlow and IPFix, we talk directly to right into the distributed switch, and you'd be pretty amazed how much east-west traffic you're not aware of. So that really helps you to understand your traffic. And I highly recommend, if you are going to go down the NSX route, is using a Vernie or even a log insight if you don't have Vernie to kind of see what's out there, what your traffic looks like. And Vernie has a feature in it that has a recommended firewall feature. So basically, based on the traffic patterns it's seeing, it's going to recommend your firewalls within NSX, which makes life a lot easier. So, any other questions?
Cool. Thanks everybody for listening.
Yeah, thank you. Thanks, Ben.
Great question. Great session.
Awesome.
Thanks, John.
Thanks, guys. So that's pretty much all I had for today. Just wanted to thank everyone, all of our speakers today, Chris Wolf, Niran, Yury, Frank, Chris, Jason for hanging out, for jumping in with the questions, and great stuff. So I'll look to put together other virtual events, and we'll go from there. Maybe even like we'll try to do an evening and do like a virtual happy hour or something one night. So
Cool.
I'll settle for a VMUG at the local university. It's fine. Just getting out of the house and seeing people, that would be great.
yeah, I'm looking forward to that too. Hopefully we can get there at some point. So take care, guys.
Ben,
thanks for joining today.
Thank you, Ben.
You guys. Bye.
Stay safe, everybody.